Ini kejadian pindah cari kabel.
Dia pakai layar belakang, jadi nggak nampak. Pasang dulu.
Siap-siap waktu Indonesia.
Siriah Balipe, Siriah Pinang, Siriah dari Pulau Sumatera. Pamanikato salamai datang. Awal bismillah, pembuka acara.
Bismillahirrohmanirrohim. Melati kuntum tumbuh melata, sayang merba di pohon cemara. Assalamualaikum warahmatullahi wabarakatuh. Bulu nyokato membuka acara.
Kawasan Mande sungguh fenomenal. Rendang lokan menggugah selera.
Salamai datang di acara seminar internasional di Universitas Andalas, Kota Padang tercinta. Ladies and gentlemen, welcome to beloved city, Padang as the capital city of West Sumatra. As the gateway to Minang Highlands, you'll find the authentic of beautiful culture and priceless history that's still being kept.
Each of nature beauty we can find in every step we walk. And there you are, a knowledge history of Minang culture from villager keeping their joy of tradition through Pacu Jawi, Tilai, and the Pagaruyang Palace.
Uniqueness of West Sumatra. Welcome to the second conference on innovation in technology and engineering science, or SITES 2.
It's honor for me to inform that there are present among us the Honorable Rector of Andalas University,
The Honorable Dean Faculty of Engineering,
the Honorable keynote speaker today,
the Honorable all participants who joined this conference.
So, first of all, let's say thanks to our God for His bless so we could attend this amazing conference. Secondly, salawat to our Prophet Muhammad Sallallahu Alaihi Wasallam. To start our event, first, agenda, let's sing the national anthem together.
Indonesia by Marsha Fadli. The time is yours.
Assalamualaikum warahmatullahi wabarakatuh. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. إن هذا القرآن يهدي للتي هي أقوم ويبشر المؤمنين يعملون الصالحات أن لهم أجرا كبيرا وأن الذين لا يؤمنون بالآخرة أعتدنا لهم عذابا أليما ويدعو الإنسان بالشر دعاءه بالخير وكان الإنسان عجولا صدق الله العظيم. السلام عليكم ورحمة الله وبركاته.
Hopefully this event will running well. Then we will continue the prayer by Dr. Eng Desto Jumen. Time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Bapak dan Ibu hadirin acara pembukaan Conference on Innovation in Technology and Engineering Science, Fakultas Teknik Universitas Andalas yang dirahmati Allah SWT. Di awal acara kepada acara kita dari awal hingga berakhir. Allahumma sholli ala Sayyidina Muhammad Sayyidina Muhammad wa ala alihi wa sahbihi ajma'in amma ba'du. Ya Allah, ya Rahman Rahim, dan syukur tercurah kehadiratmu atas segala nikmat yang baik peserta maupun panitia konferensi agar dapat melaksanakan acara ini dari awal hingga akhir nanti dengan lancar, aman, sehat,
Thank you. Firstly, welcoming speech from organizing committee who make this conference happen. Let's invite Dr. Oknovia Susanti. The floor is yours.
Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to thank Allah because of His mercy, we can have this online conference today. Secondly, I would like to send salam for our beloved Prophet Muhammad Sallallahu Alaihi Wasallam. Ladies and gentlemen, we are very pleased to welcome you at the second conference on innovation in technology and engineering science held on November 4, 2020. This conference is organized by the Faculty of Engineering, Universitas Andalas, and supported by Universitas Andalas. This conference gives an exciting opportunity for engineers and scientists to enhance their knowledge. There are more than active presentation in 5 research fields that contribute to important role for the success of this meeting. I appreciate for all the keynote speakers today, and I am very happy now because my ex-supervisor, when I have tech master degree at UTM 20 years ago, can also join this conference. Thank you, Professor Muhammad Nasir Tamim. Finally, we wish that all the participants find this event is beneficial, which can stimulate creative exchange of ideas and will be personally rewarding. The big thanks to all committee for their excellent work. We believe that this event will not happen without support of all participants and the organizing of committee. Hopefully, you will have a fruitful discussion with colleagues and please enjoy this event. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you for the organizing committee to make this event happen. The next one, welcoming speech from Dean Faculty of Engineering at Andalas University. Let's invite Professor Ikhwana Elfitri, PhD. Time is yours.
Baik, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. I'm happy and honored to welcome all respected speakers and participants to the second conference on innovation and technology in engineering science. The Faculty of Engineering at Universitas Andalas, as the host of this conference, proudly presents this international event to scientists and engineers to share knowledge and disseminate research findings and innovation. Hosting this conference is our contribution to international efforts to support and boost innovation in technology and engineering science. In line with our global vision, it is a great pleasure for us to mention at this moment that 3 of our bachelor programs have just been ABET accredited: Mechanical, Industrial, and Environmental Engineering. We wish in the future for more contributions and innovation from our academics, students, and alumni, along with international researchers to solve global challenges. We want to raise a high appreciation to 5 distinguished keynote speakers: Dr. Bernardi Prangono from Sheffield Hallam University, United Kingdom, Professor Minoru Sasaki from Gifu University, Japan, Professor Dr. Muhammad Nasir Tamin from University Technology Malaysia, Professor Masami Furuchi from Kanazawa University, Japan, and Professor Dr. Eng Gunawarman from our own Universitas Andalas, Indonesia. Let us all applaud to them. We also send our keynote speakers many thanks for sharing their thought, knowledge, and experience. A big thank you also goes to all persons, institutions, and industries that have helped and supported us in hosting this event during a hard pandemic time. Thank you also to all committee members. We hope that all authors, presenters, and audience would get a massive benefit from this international conference. Hopefully, everyone enjoys every talk. Once again, thank you to all who have contributed to supporting this international conference success. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, sir. Let's invite Rector of Andalas University to give the welcoming speech, also to open this event officially. Ladies and gentlemen, please welcome Professor Dr. Yuliandri. but will be presented by the Vice Rector of Andalas University. The floor is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi washabihi ajmain. First of all, I would like to say apology from the Rector Andalas University, Professor Yuliandri, since he is not able to attend this meeting this morning. And I'm assigned by the Rector to represent him and to give opening speech this morning. Good morning, ladies and gentlemen, distinguished guests, and also keynote speakers. First of all, we would like to welcome you all to the second conference on innovation in technology and engineering science. Of course, this is a very important event for Andalas University, especially the Faculty of Engineering, that has been able to hold this important event, although we are not in normal condition. So we are really appreciate the Dean of the Engineering Faculty, Professor Ikhwana, and also the committee, Dr. Octavia Susanti, that has been working very hard to prepare this event. So again, thank you so much for the Faculty of Engineering. And this is a part of our activity that can contribute to the performance of Andalas University. So again, thank you. Then we also would like to thanks to the keynote speaker that have been given the time to come to this meeting. We would like to mention the Professor Muhammad Nasir Tamin from UTM, and then Professor Gunawarman from Universitas Andalas, Dr. Bernardi Prangono from Sheffield Hallam University, Professor Masami Furuchi from Kanazawa University, and Professor Minoru Sasaki from Gifu University. Thank you so much for your time and for your contribution to this important event. And we are really appreciate this event. We know that this is an important conference in terms of changing idea, changing research, and also because the theme of this event is about innovation. Innovation is, of course, one of very important tools for society, for us to make the society better. So from business point of view, innovation will, of course, view as tools to get more profit. But from the state point of view, the innovation is, of course, in order to improve the society welfare. So we hope that this conference can contribute to changing ideas and also sharing the research, sharing the innovation that can improve the society, welfare of the society in the world, and of course in Indonesia. Again, we would like to apologize for any inconvenience happened to this event, since at the moment at Andalas University we also have a trouble in our infrastructure connection. Hopefully this can be solved quickly by our LPTK team. So anyway, we hope you all enjoy this conference and contribute to additional stock of knowledge in the world and of course in Indonesia. On behalf of the Andalas Universitas Andalas, Rector Universitas Andalas, so I open this conference officially. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
As this event had opened officially, this event will be divided into 3 segments. We already have 5 keynote speakers from
Andalas University, Indonesia, University Technology, Malaysia, Gifu University, Japan, Sheffield Hallam University, United Kingdom, and Kanazawa University, Japan.
Next segment will be led by each moderator. Time is yours.
Hello. Hello, organizer. So according to the schedule, I should start the keynote speaker number 1 at 9:30. So now it is still 9:16. So should we wait or should we go? According to the schedule, it is 9:30 for keynote speaker number 1, but now it is 9:17. So I am the moderator. Should I go or should I wait?
Okay, so sorry for our mistake. So the next is session break. We will show the traditional dance. Thank you.
Melati kuntum tumbuh melati. Assalamualaikum warahmatullahi wabarakatuh. Mulo nyokat to membuka acara.
Kawasan Mandesu.
Selamat datang di acara seminar internasional Universitas Andalas. Padang tercinta.
Ladies and gentlemen, welcome to the Capital City of Bosnia. As the capital of Ireland, we have opened the beautiful culture, such as history that
من الشيطان الرجيم. بسم الله الرحمن الرحيم.
Okay. Next segment will be led by Ferry Afrinaldi, PhD. The time is yours.
Okay, thank you, organizer. Assalamualaikum warahmatullahi wabarakatuh. Can everybody hear my voice?
Yes.
Okay, thank you.
Yes.
Okay, thank you. So, welcome to the first keynote session of the second conference on innovation in technology and engineering science. I am Ferry Afrinaldi, and I will chair this keynote session. Let me introduce the keynote speaker. He is Professor Gunawarman. He is a professor in mechanical engineering at Universitas Andalas. He is an expert in the area of materials engineering. He is the author of hundreds of articles published in respected journals and conference proceedings. He is also the author of 2 books in the area of materials engineering. And he has patents and intellectual property rights. So the title of his presentation will be The Effect of Hydroxyapatite. I'm not sure if I said that correctly. I'm sorry for that. So I repeat, the title of his presentation will be The Effect of Hydroxyapatite Coating on Surface Properties of Titanium Alloys for Biomedical Applications. I am an industrial engineer, so I have tried my best to capture what the speaker will deliver. But I assume that he will show us the good effect of coating, the coating on titanium that we're gonna use or that they're gonna use as an implant. So that's what I got from the title of the presentation. And for the audience, we will have 30 minutes for Q&A. So there are 2 ways of asking question to the speaker. Number 1, you can ask question directly by activating your video and microphone. But if you want to do that, you need to wait until the speaker complete his presentation. And I encourage everybody to use that method. So there will be a direct engagement between the speaker and the audience. For the method number 2, you can also ask question by typing your question in the chat box. I am the moderator. I will read your question to the speaker. If you want to do that, you can start typing your question even when the speaker is presenting. I think that is it for the rule of the game. So it is 9:29. Now let me invite the speaker, Professor Gunawarman, to deliver his keynote speech. And you have until 9:50. The time is yours.
Okay, Mr. Moderator, thank you. Can you hear me? Okay, hello.
Yes, yes, I can hear you clearly.
Okay. Thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Honorable Rector of Andalas University, Dean of Engineering Faculty, all keynote speaker, organizing committee, and all audience of this conference. Let me present my work entitled Effect of Hydroxyapatite Coating on Surface Properties of Titanium Alloys for Biomedical Application. Introduction. Okay, sorry, let's stop me as host of this meeting because so many people come to my monitor to ask for admit this conference. Sorry. Yeah. Introduction. Fracture or broken bones are common problem in human life. Fracture can occur at various locations in our body. The largest order is collarbone, you can see in this picture, wrist and ankle, and so on. The most often broken side is collarbone. Can you see here, collarbone? Usually is happen at young people, especially children. The second one is ankle. This usually happen at middle-aged people. But for old people, usually get this type of fracture. This what we call as a hip fracture. Usually because it's osteoporosis. So, there are so many trigger factors for fracture. The first one is bone condition, including osteoporosis, bone cancer. And the second one is because of traumatic incident, such as traffic accident, sport, fall, etc. The number of fracture cases among osteoporosis sufferers in Indonesia is quite large, reaching 7.3%, while in the world it's about 7.1%. Many cases of fracture occur in elderly people, especially over 6 years old people. Most of them is female, with a risk level 4 times as compared to male. As you can see here, there's so many people, women has problem, has osteoporosis problem. This picture you can see here, this comparison of healthy bone in this left one and osteoporosis one in the right one, this one. Second of lost bone is very easy to break due to small impact load only. The fractured hip bone is repaired by replacing with an artificial one, so that it can be back to the normal function. In this monitor, you can see, for example, this is broken, the picture of broken hip, but after repairing, usually we use metal, like this picture, to replace the broken hip joint. The material used to replace broken bone usually is metal. The metal that are common for this application is stainless steel, cobalt chrome aluminum alloy, and titanium. Two kinds of titanium, pure titanium or titanium alloy, as you can see here. This metal is selected because is some reason. As you can see here, the first one, high strength, good elasticity, good corrosion resistance, and good biocompatibility. In the right picture, you can see the example of implant usually used by medical doctor. This is type of some implant, this plate, fixation plate, and screw, and also this hip joint. However, the use of metal implant has side effect, and other problem for human body that make implant failure or do not function properly. Types of this side effect include some of them. You can see here so many. This picture I show you this aseptic loosening. This is near this loosening of our bone near the implant. And you can see also here allergy and hypersensitivity. This is the most problem of using implant for human. In addition, metal implant can be corroded if long time exposed in our body. This is example of root dental implant. And stainless steel. This is stainless steel hip joint that has corrosion during implementation. Such kind of debris resulting from the corrosion is give bad effect to our health. So we have to avoid corrosion for the implant in our body. The metal that has good corrosion resistance and biocompatibility to human environment so far is titanium alloys. This metal is also lightweight, low high fatigue strength, relatively low elastic modulus, and good formability. However, like other metal, titanium has this advantage. This metal is properties is bio-inert. This make metal difficult to bond with our living bones. So what we have to do? So we have to make surface modification. Sorry, the purpose of surface modification is to increasing also biocompatibility, osteon conductivity, and osteon integration of metal implant in our body. Titanium alloy that widely used for implant is titanium Sigma. Why? Because this kind of this alloy is very good strength, high strength, as you can see here. Little bit how to say not so good as CP1, but this is because CP commercial pure titanium is not so strong. So usually medical doctor use titanium Sigma as implant material. So in our study, we will use this material. And we also use some new candidate of titanium alloy. This new type of titanium alloy just developed several years ago. That is, we call as TNTZ. This developed in Japan. This kind of low modulus of elasticity implant. And the second one is titanium 12 chrome, or just we call as titanium 12. This is a kind of low cost implant. Bioactivity can be improved by surface modification technique. There are some techniques that can be applied in this presentation. We focusing on maybe only two kind of method. You can see here so many: coating, gradient coating, rogening, patterning, grafting, and multi-layer film. But in our work, we focusing on coating and multi-layer film. Surface modification plays a significant role in implant integration in human body. This is because it improves mechanical anchoring in implant integration with human body. And then also improve bone conductivity, enhance wear resistance, increase corrosion resistance, improve biocompatibility and bioactivity, and shortening of the healing time or easy to recovery. In this picture, you can see his type of hydroxyapatite powder that we use in this study. Hydroxyapatite usually we can found in many shapes, not only in powder. This is typical of hydroxyapatite you can find in the market. This the rack one in the rack set one. In this you can see the picture is the picture of microstructure of hydroxyapatite. Hydroxyapatite usually called as calcium hydroxyapatite or HA. The chemical formula of this HA is this one you can see here. So hydroxyapatite usually this common in our body because of our bone consists of hydroxyapatite and also collagen. This is the reason why we use hydroxyapatite for coating material to our implant. In this study, we use coating method by using electrophoretic deposition, or we call as EPD. Because this coating method able to coat complex shape material such as screw, and also simple and low cost. Properties of each layers can be adjusted by controlling the voltage and coating time. This is working principles and instrument setup of the equipment. You can see here. Properties of each layer can be, as I said before, can be adjusted by controlling voltage and exposing time or exposure time. We have conducted some research work to find the best parameter for APD to achieve high quality of each layer in the surface of titanium. And it has been already presented in many conferences and also published in some journals. This is a sample of surface photograph of resulting from APD process. This may this microstructure is determined by SEM, scanning electron microscope. What we can see from this image is that for low voltage, the HA layer is not distributed severely. But if too high, the layer become easy to crack. So the best one is the middle. This is about 10 voltage is about 10 V. You also can see here surface of afferent of hydroxyapatite for 10 V. This is V control again. You can see here the appearance of layer different to the time of exposure time. The best one is, you can see also the middle. If the coating time is too low, the layer is not so good, not so, how to say, distribute evenly. But if too high, there is a crack. So the middle one is the best. This is trend of layer mass as a function of voltage for three types of titanium alloys. That is titanium 12, titanium 64, and 10Tz. We can see that the layer mass increase with increasing applet voltage. There is a difference of gradient for each alloy investigated. Thickness of layer on titanium alloys also depend on time and voltage. You can see here for titanium 12, the thickness is relatively constant for the given voltage, but for two other titanium alloy increase with increasing voltage or coating time. This is effect of voltage and exposing time to surface coverage of each layer. This is the most important surface characteristic to make sure all the surface is coated by the HA. We can see here only titanium 12 can cover all the surface by low voltage and short time of exposing time. For titanium 64 and 10Tz, we need a higher voltage and longer for covering all the surface. We also conducted effect of particle size on the surface coverage. As you can see in the result is in this you can see in this monitor. Particle size has significant effect on the surface coverage and adhesion strength, but not to the coating thickness. Small particle size produce a high surface coverage and good adhesion strength. You can see here, this is the small, this the last one for good adhesion strength for small. This is size in micrometer size. We are also trying to use natural SA for coating material. The natural SA was extracted from wasted bovine bones. The natural SA has a lower adhesive strength than the commercial one.
Yes, speaker, you have 2 minutes left.
Okay, thank you, moderator. I will have to say faster than before. Okay, let's just. We also use collagen coating process on 10Tz. This uses collagen, as I said before. These two kind of the best coating material, hydroxyapatite and collagen. The result is like this. If we use collagen as coating material, we get quite good properties, surface properties, as you can see here. the best parameter for getting good coating surface is by using by the coating is 5 minutes coating time and at 4 centigrade to obtain surface coverage severely. Temperature variation have no significant effect for a thickness of the cutting surface in the case of collagen. We also try to check the quality of coating material by using in vitro tests. Using, as you can see here, we use Wharton jelly stem cell medium to determine cell viability. Both uncoated and coated TNTZ are found non-toxic. Collagen increase biocompatibility of TNTZ. Collagen also increase migration process of cell and stimulate cell response. And then we try to apply our implant to animal. This what we call as animal test for to check the quality of the surface directly to the animal. We use this kind of animal for our experiment. This is Rattus novergicus wistar or white rat. We use two kind of layer, monolayer and bilayer implant, all multi-layer implant. This type of implant screw we made by tuning process. This is the uncoated one, this is the coated one. So in this case, we inserted this bone to, we inserted this kind of implant to red bone. You can see is the schematic picture here, how to insert it, implant to the bone of the rat using standard procedure for implantation to animal. The result we can see here. This is after 2 weeks implantation. What we can see here, there is a big difference of the level of wound healing and in the implanted area between without HA and with HA. We can see here, this is, if we use hydroxyapatite, this clearly, this is fully recovery. There is no inflammation in the outside this. Also, but if we use non-coated one, there is it is not recovered yet. So this is pathology image in the right one. So many osteoblasts here, and new bone tissue formed in the implant, as you can this black arrow. We also use removal torque test for determining ocean integration. This is the picture of rotational torque test or removal torque test to know the strength of ocean integration. So you can see clearly here that the coated one has a high removal torque view as compared to the uncoated one. So this indicated good ocean integration. In the case of bilayer essay coating on titanium 64, you also can see here this is the performance or appearance of the coating layer. We use, as I mentioned before, use two kind of layer. The first layer is nano layer, and the second one is micro layer. The first layer, this nano layer, is for improving ion release protection and corrosion protection. And the second layer is to improve ocean integration and also bond growth. The result see as also in the case of single one, the full recovery is happen for the bilayer HA, as you can see here, but not for with the uncoated one. So sorry, the morphology. The morphology of cell, so the addition in the direct one, so the addition of pattern in the surface of implant. It is clear a flattened area for the uncoated titanium 64 and round tap in the case of coated implant. Such round tap confirm the existence of interaction between cell and surface of the material. This is the result of removal torque test to determine ocean integration. We also see the same thing with the single layer. The B layer of coating give good ocean integration or removal torque test by a value, especially for after 4 weeks implantation. So let me conclude our work and also in our presentation. An optimum APD voltage and exposing time required to obtain a thin and severe distribution of AC layer on the surface of in the surface are different for each alloy, depend on the alloy. And the second one, the addition strength between SA layer and titanium substrate is largely determined by SA particle size, degree of surface roughness of the material, and the thickness of the SA layer from the surface of the material. Applying titanium alloy implant prototypes to biological issue in vivo study using rat show a faster recovery with a low level inflammation, a higher level of new bone growth, and much better ocean integration for the SA coated one as compared to the uncoated one. Future work. SA coated titanium alloy has been excellent perspective to use as future prosthetic implants. However, some advanced investigation are still needed to improve the quality of the implant surface, especially for a more complex shape and bigger implant prototypes. In the near future, in vivo study with a higher animal taxon should be conducted before moving to the test into clinical trial. That is our work reported to you. Thank you for your attention. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Professor Gunawarman. That was an interesting presentation. And I think we have about 30 minutes. According to the schedule, we have 30 minutes for the Q&A, but now we are about 10 minutes behind the schedule. Let me see what I have in the chat box. I have nothing yet in the chat box. So I assume that everybody want to ask a question directly. If you want to ask question directly, please activate your microphone and your video and say your name and your institution. Anyone, please. Ask anything to the speaker.
You can ask by English or Bahasa, I think.
Yeah, I will. Yeah. Of course, he understands Bahasa also. Of course, that is his native language. We have around more than 200 participants. I'm still waiting for the question. But anyway, I'm going to start from me.
Yeah.
So I'm an industrial engineer, so I try my best to follow your presentation, and I hope that I can give you a quality questions. Okay, this is the thing. You test your implant to an animal, right? I'm not sure that is a duck or a chicken. I don't know. So I see that you try to see the biological effect of the implant.
Yeah.
And you reported that there is no inflammation after 2 weeks.
Yeah.
Right. So my question is that what about other biological effects such as irritation, sensitization, and other effects? Because I'm sure that that animal cannot tell you what it feels. That's the first question from me.
Okay, Mr. Ferry, thank you very much. Your question is very good question. I think that even you industrial engineers, you have a good question. I think in our case we use rat, white rat, Rattus navigatus wistar as this is usually used as animal test for animal test in medical biomedical field. In this case, we, as I said to you, we just check effect of ocean integration and bone growth. So actually, there is so many effects, not only ocean integration and bone growth, but many things. Also, immunity, hypersensitivity, allergy, and so on. But usually, it takes long time to check this effect. In the future, we can try to test what effect of the implant, coating implant to such kind of properties, as you said before. So because in our case is material science, we don't know so much about how to check properties like you said, hypersensitivity and also allergy. Yeah, usually this disease or this characteristic appear after long time exposing in our body. So as I can in this case, we just limited to check even ocean integration and bone growth. The next step, we can do that as you said. Okay, this makes sense. Can you my answer? Okay.
I got it. So for this step, until this stage, you have not included the other biological effects such as the irritation, allergic, sensitization, and other biological effects. So that gonna be the future work.
Yes, that's right.
In the area, and you may need collaboration from people, I don't know, from medicine, biology, or so because you are an engineer, so you because we are not an expert in the area. So thank you. So that's clarify my questions. And again, I am inviting the participant to ask question. Please type your question in the chat box or activate your microphone, activate your video, and ask the speaker directly. And if you want to do that, then you need to mention your name and your institution. We have more people now. We have 211, and I don't know, maybe.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, say your name, sir.
My name is Dodi Budiana from Universitas Indonesia.
Yeah. Okay.
Sorry, my background is in electrical. Maybe I want to ask about the for the coating is using the electric coating, sir.
Yeah.
And then how about the thickness? How about the thickness of the thing? This minimum thickness or other standard for the thickness?
Yeah.
Maybe there's my question.
Okay, thank you. Question. Sorry, moderator. Mr.
Yeah.
Dodi, I'm not sure the name of
Yes.
Mr. Dodi.
He is Dodi Budiana from Universitas Indonesia. Yeah.
Universitas Indonesia. Thank you very much for your question. A nice question, I think. Yeah. The thickness of each layer, as you can see here, depend on the voltage and also time, coating time or exposing time. So actually, we need very thin coating layer is the best one for medical application or for implant. Usually we use less than 100 micro. It is the best one according to medical standard. So in our case, if you can see here, this we just how to say control. We control the thickness of our coating layer less than 100. Yeah. If too thick is not so good. But if I think usually it is better the very thin. But if very thin, it's difficult to get a surface coverage. How to say severely on the surface of the material. So usually we need at least 50 micron on the surface. So the best one is between 50 to 100 micrometer. This also according to experience of medical doctor. So in this case, we can get this sickness, this kind of sickness. But how to say, for surface coverage is quite different. So this, Mr. Budi, this is my answer.
May I ask again, Mr. Gunawarman?
Okay.
It is different if you use different base material, maybe different base material or different application. Gitu. It is different thickness or the same.
Usually is the same for any material. The thickness of how to say needed for implant is around 50 to or less than 100 micron. But to get such kind of thickness, the parameter for APD is different. APD, the diameter for getting how to say target thickness, it is quite different. But the standard for the thickness is almost for all material, implant material, including stainless steel and titanium.
Okay, thank you, Mr. Professor Gunawarman.
Yeah.
Thank you, Mr. Moderator.
Okay. Thank you, Pak Dodi, for your question. I just want to follow up his question, Prof. Gunawarman.
Yeah.
So he was asking about the thickness. Will it be different if you put the implant in the hip, leg, finger, neck? Will the thickness will be different, or they are all the same?
Okay, very difficult question because I have no experience. This is actually used for orthopedic. I mean, just for how to say coating the bone and at the bone, not for example in the soft tissue, only in hard tissue. I don't know exactly what kind of how to say how thickness we need for soft tissue, as you said. Yeah, but for hard bone is similar. Even of, for example, hip in your hip, ankle, tibia, femur, even on our how to say head head of your body. This is also similar. They hard tissue, and this is similar usually, but not for soft tissue may be different. Soft tissue including skin and also how to say heart and other. Okay.
Okay, thank you. Thank you. Again, I am inviting the participants to type your question or to activate your microphone and video.
Good morning, sir.
Yeah.
Morning. So say your name and your institution.
My name is Hasbi Fadli. I'm from University of Indonesia. Good morning, Pak Gunawarman.
Yeah. Good morning, Hasbi.
I think this one is interesting innovation in material related to human health. My question is, has this innovation ever submitted or communicated to Ikatan Dokter Indonesia for giving new alternative in solving a corrosion material that implanted in human body? That was my question.
Okay. How to say good? I think thank you for your kindness. Yeah. Also, we also discussed with a doctor in Andalas University. This work actually also advised by a medical doctor. So in some case, we don't know actually what is the user needs. So we have to discuss to the medical doctor the kind of usually the problem of a medical implant in how to say based on the medical doctor experience. So we cannot how to say working just with engineers. In our case also we our collaborator is from medical faculty, medical doctor, I mean, and also we have collaborator from science, especially biological sciences. So we need many input for them. Also, we submit this result to medical doctor. Yeah, maybe they can use or give any suggestion for us to complete our work. Okay, thank you, Hasbi.
Thank you, Pak.
Yeah.
Okay, Pak Havi, is that answer your questions, or you want to add more? Okay, so okay, that is it. Thank you. So, anything else from the audience? I still have nothing in the chat box.
Dr. Ferry? Dr. Ferry?
Yes. Yes.
This is Nasir, Muhammad Nasir Tamin from University Technology Malaysia.
Yeah.
I have a short question. Coating that you put on the femur, it is meant for biocompatibility or resistance.
Yeah.
However, now there are many cases where the implant actually failed due to cracking. due to the gate cycle, so it fatigue, it cracks, right?
Yeah.
So when you put a new layer, you are actually introducing a new unknown. How would you ensure that this new coating improve the resistance to crack initiation? Because once crack initiate, it's going to propagate, then it's not going to be good. Yeah.
Yeah.
Thank you.
Okay, thank you your question, Prof. Nasir. This is I think good question. Actually, this because we use hydroxy apatite or collagen for coating material is not so influence of how to say knots in the surface of material. This just is how to say something like soft materials. So maybe I think there is no scratch and something knots in the surface of material that can put how to say initial crack, give initial crack to the surface of the material. So this is from how to say from other literature or from our experience, yeah, not so good, and not so how to say has big effect. I think no effect. Also, the how to say this material coating material, this just temporarily. Usually, this coating material can be disappear after a long time. Yeah. In the surface because how to say reaction for biological tissue. So then the surface of this material is keep clean or keep to say smooth. So this is also why we use actually, as you know, we need actually the coarse how to say not coarse material, surface material, not so smooth material. Smooth material in the surface good for fatigue strength, but not for ocean integration. So if we use coarse material, good for ocean integration, but bad for fatigue. Fatigue strength because how to induce crack initiation. So in this case, we using a relatively smooth surface to how to say to obtain high fatigue strength. But the problem how to make this how to say implant have good ocean integration. So we have to use other material to how to say to combine actually combine. We keep a good fatigue strength by using this smooth surface of material, but for coarsening of the surface we have to use hydroxy apatite or collagen. This is just something how to say interface layer. Yeah, between metal and hard tissue. That's my question, Prof. Nasir.
Thank you. Thank you.
Okay, Prof. Nasir, you have anything else, or you are good with that?
That's fine.
Okay. Thank you. Okay, I think we still have time, so I don't know if I have to stick to the schedule because now. Because at the beginning we were 10 minutes behind the schedule, but anyway, we still have 2 minutes before 10:20. So okay, this is from me again. I'm gonna follow up what Professor Nasir Tamin asked you. So he mentioned regarding the crack resistance. Now, at the beginning of your presentation, you mentioned that the titanium has a good corrosion resistance.
Yes, that's right.
Right. Yeah. Now, my question is that how likely that the titanium that you use as an implant will have corrosion?
Yes.
Will it have corrosion someday, or it will never have corrosion?
Yeah.
Yeah.
Okay. good question. I think this titanium has good corrosion resistance. This among all metal. I think among metallic materials. Yeah, but actually all metal, how to say, will corrode, yeah, after long time, including titanium. Yeah, so we use actually not good for very long time, just for a short time. The maximum use, how to say, for our body, based on the experience, 15 years. How to say, in the body, but after that maybe this corrosion will happen. So good corrosion resistant means just at first in air condition, but in our body, because of so many how to say, so many salted liquid. I think salted liquid, how to say, this is very dangerous for metal. In the case of, if we use in our body, this for titanium alloy, we have thin layer in the surface, we call as titanium oxide, to keep or to protect our titanium become high corrosion resistant. But unfortunately, if we use in our body, this kind of thin surface can be damaged by liquid or body liquids. Actually, this our body liquid is how to say, the pH of our body is about 7, but in some condition maybe less than 7, maybe become acid liquid. This is dangerous for our body. So the implant can be damaged by how to say, body liquid condition. As you know, if human in bad condition or in stress, and also others in maybe disease, the how to say, body liquid also, the pH of the body liquid also changed. So this is they can, why even of titanium has good corrosion resistance. If we how to say, use in our body, they still can corrode it. So this is the first one. But as I said before, this what this not only for how to say, we give coating not only for enhanced corrosion resistance, but the important one, how to make this how to say, the bond can grow or good corrosion integration in the surface. Because if no integration, how to say, there is a loosening. How to say? How to say? There is no bond between implant and how to say, bond loosening. So maybe our implant can easy to remove from our body. How to say? Because not so tight. So actually, this we improve the tightness of the implant can be how to say, joint very tight in our body. This if not so tight, there is a problem. This how to say, easy to break this implant. In some case, this from experience, some of implant, especially for fixation plate in the tibia fracture, a medical doctor reported how to say, the failure of implant because of loosening of the implant. So there is some how to say, purpose why we have to put coating in the surface of material. Okay, this
Okay.
yeah.
Okay. Okay. So thank you. That answer my question. So as you mentioned that the one that you pay attention is that how the bone will grow, right? With the implant. Now, the next question from me: what about the Young's modulus between the implant and the bones? Because when there is a mismatch in the modulus of the titanium and the bone, then your titanium will put more stress to the bone. So how big is the difference between the implant that you use and the Young modulus of the bone?
Yeah, very good question, Mr. Ferry. This is also why we use titanium. Actually, we have to along modulus elasticity of implant close to bone, over bone. Modulus of elasticity of human bone is about 20 MPa. But how to say, if we use a material such as stainless steel, the modulus of elasticity too high. This is also the problem. So we use titanium because it's the modulus of elasticity close. Closest, I think closest implant material to the bone. We also developed, as I said to you, we developed new titanium alloy, TNTZ. This is such kind of low modulus of elasticity, close to bone. This is also important. If we used to use high modulus implant, this also how to say lead to loosening, or how to say what loosening and other problem. Actually, our bone need to how to say movement. How to say maybe should be how to say has elasticity. So if we use very strong implant, so our bone become passive. So our bone become how to say loosening, or become dead. How to say not growth properly. So this is why also we use titanium alloy. This to make how to say not how to say the implant also can how to say permit the bone for a little bit strength or elasticity. Not all loading how to bear by the implant, but the bone also need load to make this active, not passive. So that is my question. So we need low modulus implant. So that's also the reason why we use titanium, especially low modulus titanium, TNTZ, as I mentioned in my presentation. Okay.
Okay.
Mr. Ferry.
Thank you, Professor Gunawarman. So last chance for the audience. If you want to ask questions, you can activate your video, your microphone. We still have, I think, 2 minutes before 10:30. Let me check my chat box. I have nothing in the chat box. So I think that is it. Thank you very much to the speaker, Professor Gunawarman, for your presentation. It was a very, very nice presentation. And thank you very much to the participants for your participation in asking questions. So if I can conclude the keynote speech, so I can say that the titanium, it is a very, very promising material that we can use for implant, but still there is still more that we need to investigate. For example, the biological effect, the crack resistance, where we can put it in the leg, can we put it in the hip, can we put it in the neck, can we put it in the head? So we still need more investigation on it. And I think as an engineer, we need to collaborate with people from biology. We need to consult with the doctor and other people from the medical area. Again, thank you very much for the keynote speaker, and thank you very much for the organizer. I think this is it from me. I conclude this session, and I hand it over to the organizer. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Organizer, I hand it over to you. You can take over now.
Thank you for the discussion. The next is for the commentary. We would like to take a photo of all the participants. Please turn on your camera and stand by for some couple of minutes. For the first screen, please wait for a while. The second, the next slide. Please turn on all of the camera. We would like to take a picture of all the participants. There is still a participant that still turn off the camera, so we would like you to turn on the camera. There is still a lot of participants still with camera off. So please turn on your camera for the commentary session. Thank you. Thank you for all the contribution. So the next segment, the keynote speaker from University Technology Malaysia with leader by Ismet Hari Mulyadi PhD as moderator. Time is yours.
Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning for you all. Sorry for late response because I have to change my background first. His Excellency Dean of Engineering Faculty and the honorable keynote speaker and of this conference and all the respectable participants, I welcome you to this conference that held in Padang, West Sumatra. First of all, I would like to introduce myself. I'm Ismet Hari Mulyadi. It's my pleasure to serve you as a moderator for this conference. Yeah. In this session, we will hearing a talk from Professor Nasir Tamin. Professor Nasir Tamin is a professor of mechanical engineering and solid mechanics as well from University Technology Malaysia. Since he's graduated from his doctoral program in 1997 or 1991, yeah, he already gained so many experience and reputation as well in the field of solid mechanics. Yeah. He also contributed to so many papers from journal and proceeding that cannot I mention one by one in this at this time because we have sorting time. Yeah. On this very timely subject, he would share a knowledge about structural reliability assessment framework with damage-based material mode. Yeah. Professor Nasir will do a presentation for this topic around 20-30 minutes. Yeah. Next, after that, we will follow with question and answer about 20 minutes. Yeah, 20 minutes. So I think because we have a short time, yeah, I will move along to our session. Yeah. I will give a control to Professor Nasir to present the topic. Yeah, please, Professor Nasir.
Thank you, Dr. Smith. Can the host allow me to share my...
Yeah, we'll do it. Okay. Host, please you help me.
Already?
Okay, yes, Dr. John, thank you. Okay, yes, Professor Nasir, please.
Okay, can you hear us fine?
Yeah, it's fine.
Thank you. Again, thank you, Dr. Ismet. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good morning, colleagues, ladies and gentlemen. First, our gratitude to the organizers of CITES 2020 conference for this opportunity to share our research and development work. My name is Muhammad Nasir Tamin, and our presentation is on structural reliability assessment with damage-based material models. We acknowledge our colleague, Dr. Wan Fahmin Ali, who is working on this project. And this is an ongoing project at the School of Mechanical Engineering, University Technology Malaysia. And we will align our presentation in addressing the CITES 2020 conference theme on sustainable innovation in engineering business for better future. Let us begin to describe the problem using a couple of examples, couple of load-bearing examples. We have here steel wire ropes used in mooring of offshore structures or FPSO, and the steel wire ropes experience complex loading that include tension, torsion, and also bending due to the sea current and its own weight. We could also have aerostructures components such as the spoilers made from carbon fiber composite laminates and subjected to wind pressure distribution. Now, this loading is oftentimes fluctuating, this time varying, and this gives rise to the structural reliability issues. How long will the structure last while they are in service? Now, let us look at what do we have in order to address this problem. Many of us have worked with developing constitutive models to describe the response of materials to loading and consider strain rate effect, temperature effect in the stress strain equation, while others work in the fracture mechanics area to predict the fatigue crack propagation. So we do have some tools. Another scenario is the fourth industrial revolution, or IR 4.0, which is described by the cyber physical system. So this features, among other things, the acquisition of big data and the analysis of this data stream using cloud computing, for example. And we capitalize the IoT, Internet of Things, for monitoring the system and control of the actuators and sensor. And we employ artificial intelligence, augmented reality to aid us in decision-making for structural safety and reliability. So in this presentation, we try to illustrate the potential of integrating the damage mechanic-based material model within the IR 4.0 framework. So the objective of this work is to develop the working framework for the reliability assessment of engineering structure, incorporating damage-based material model. The remaining of this talk will follow the following outline. We will introduce the proposed reliability assessment framework and describe the damage mechanic-based model, in particular the damage concept, and introduce the case study material for illustration, that is the carbon fiber composite laminates. We will deliberate the final element simulation requirements and also discuss the process on how to generate the damage curves. So here is the framework, and it consists of several components. We have the application equation with embedded sensors as a means of acquiring the live data. So the material module here will quantify the state of damage of the structure based on this data. Now we take the damage level to the decision-making algorithm with the aids of artificial intelligence, IoT, that shall mitigate the safe operation of the structure. So in the event that the structure is reaching the critical damage level, then the manual decision, human interruption based on the outcomes of finite element simulation of the damage component, then a unique operational decision shall then be employed. Let us now take a closer look at the requirements for the material damage module. The task is to develop the characteristic damage curve of the material over the expected operating load range. We begin with the damage, material damage, which is manifested in the progressive deterioration of stiffness and strength properties of the material due to fatigue loading. The damage itself, D, is viewed as the ratio of the area of these defects over the total area. And at the mesoscale, the analysis is done within the continuum damage mechanics by scaling the Cauchy stress tensor with the damage value. So this concept is applied to fiber reinforced composite as illustrated in this figure. The unidirectional lamina is viewed for the analysis as an equivalent homogeneous orthotropic material Now, loading will induce damage that is manifested in the form of microvoids and microcrack. However, the analysis is done on the fictitious, undamaged state with the stress or the viscosity stress tensor scaled by the damage value. We now discuss the case study material. Carbon fiber reinforced polymer composite laminates, where the interfaces between the laminates are the weakest link with respect to failure. So we consider a piece of the composite laminates with mid-plane interlaminar crack subjected to the loading condition as shown here. So the thin or mathematically zero thickness interlaminar layer would then experience normal stress component and the shear stress component. When the applied load fluctuates in fatigue, the analysis would then need to consider the load cycle induced interlaminar damage. So in this respect, we already have the cohesive zone model of the interface. It is available to predict the damage, but under monotonic loading. For this model, the traction or the stress displacement response is described by a bilinear softening law. The interlaminar damage initiation is then expressed in terms of the quadratic stress over strain criterion, while the subsequent evolution of the damage is described by the energy-based criterion. We modify this cohesive zone model to account for the fatigue-induced damage. This damage is manifest through the degradation of the interlaminar properties. Degradation of the interlaminar properties with the increasing number of accumulated load cycle, illustrated here for the shear traction component and relative displacement in shear, but similar process is assumed for the normal traction component. Now, for fatigue, each of the fluctuating stress would consist of the amplitude and or the fatigue and the mean component. This is non-fluctuating component. Therefore, the degrading interlaminar properties, it contributes towards damage initiation event in a similar form of the quadratic criterion with the mean or non-fluctuating component. Now, the new challenge now is to establish these residual properties. In particular, the strength, the stiffness, and the energy release rate for the normal and the shear loading mode. Now, the interlaminar property degradation due to the fatigue loading could be quantified in terms of the residual properties of the material, and for the relatively low stressing of the interface, the strength property would degrade down to the maximum operating stress level of the structure to cause failure. Now, let us now illustrate how the characteristic residual interlaminar shear properties of the CFRP composite laminate were established. What we do is, we perform the 3-point bending test on end-notch fracture sample, a piece with crack under 3-point bending test. Now, the loading would induce a dominant shear stress on the interlaminar plane with a maximum magnitude along the initial crack front. So the measured load or global load deflection would increase linearly, and that indicates the elastic non-damage deformation, and this would go all the way up to the level where the significant slope reduction or the stiffness reduction occurs at this point. So this indicates the corresponding initiation of the interlaminar damage inside the material. And it follows next with a sudden load drop that signify the brittle crack extension. Now, once we have these now, how do we extract the much needed interlaminar properties from this global load displacement curve? We introduce a combined or a hybrid experimental computational approach employing finite element analysis. We perform the elastic finite element model of identical N-notch fracture sample, and we simulate the 3-point bending test. Now, the load displacement response is calculated, the red dashed line is calculated up to the observed onset of damage. So at this load level, the interlaminar shear stress should have reached the corresponding shear strength. And at this level now, we open this the model, and this shows the variation of the shear stress along the interlaminar crack front. Therefore, this shear stress level is then taken as the interlaminar shear strength of the material. In addition, the finite element calculated shear stress evolution versus the relative shear displacement at the critical material point that is located at the mid-width of the crack front would provide the penalty stiffness property, which is the slope of this curve, while the mode 2 strain energy release rate is obtained independently. So these only provide the reference static properties of the interface. The residual interlaminar properties, they are established in a similar procedure. The N-notch fracture sample is loaded with specific fatigue loading and for specific number of load cycles. Then the fatigue that is meant to damage the interface crack front region. Then once the number of cycles is reached, the fatigue specimen is then loaded to crack extension. The load displacement is recorded, and then we illustrate now a typical response of the test for this case, for example. For this loading to the 50,000 fatigue cycles. So we have the loading 200 Newton at the load ratio of 0.25 and cycle for 50,000 cycle, and then we do 3-point bending test to fracture. Now, the load displacement response, this red line here, is compared with the S-fabricated non-fatigue specimen, and this inferior or the lower response is indicative of the damage that is induced by the fatigue loading. Then we need to do finite element simulation of the 3-point bending of the fatigue specimen. However, the required input of the residual properties is not known a priori. We do not know it. This is a chicken and egg kind of a situation. So we initially estimate the residual properties through a linear scaling of the measured global stiffness curve. Then the simulation is reiterated with the improved estimate of the input residual properties until the computed finite element load displacement curve compares well with the measured data. So let's look at the results of the sample run. This is for run 1 with this loading. We show here the residual properties normalized with the respective static value, and the number of cycles normalized with the cycles to failure. And it shows here that the shear strength properties, it degrades to the maximum shear stress level, which is around 45% of the shear strength value. Now, it is of computational interest to represent each of the residual interlaminar property corresponding to the different stress cycle in a single normalized curve. So in this respect, we introduce a live parameter to represent the mean stress effect. This tau m here, the mean stress effect on the terminal fatigue life of the interlaminar for the interlaminar, or based on the interlaminar fracture. Now, the residual, so that number of cycle to failure is here. So the residual interlaminar properties is then presented in the normalized form. In the graphical form, we have the residual interlaminar shear strength normalized with the static value, while the fatigue here, number of cycles, is normalized over the fatigue life of the component. And the test data for 3 different load conditions converge here, and we feed them through the best fit with 2 parameters, alpha and beta. And we do similar analysis procedure for the other 2 interlaminar properties, which is K sub S, this is penalty stiffness, and also the shear fracture energy. Now, let us then revisit our framework. Now that we have the damage-based model of the interfaces in the composite laminates, meaning that we have the tool to actually generate the characteristic interlaminar damage evolution curve for the operation. We then would like to illustrate the process on how to generate the reliability data, that is the interlaminar fatigue damage evolution curve of every material point on the interface. We model the lamina with the mid thickness crack under 3-point bending, and we apply a specific loading condition and the boundary condition, and that will generate the shear loading at the interface plane, interlaminar plane. Now, then we monitor the evolution of fatigue damage at every calculation point on the mid plane, on the mid plane of the specimen. And shown here is the calculated evolution of fatigue damage initiation variable of the critical point, which is the midpoint here located at the mid-width of the interlaminar crack. So denoted as P1 here. Now, the variable actually represents the inherent interlaminar property degradation over the fatigue cycles. We see that for the first few cycles, the variable only reached 0.21, which means that there is no damage yet. If we go to larger number of cycles, and this is the same plot here, damage variables versus number of load cycle, and this is the same curve. As the number of cycle goes, and this result shows that it takes around 190,000 cycles for that critical point to reach fatigue damage initiation. And following fatigue damage initiation, the damage would actually evolve with this variable value reaching 1. Reaching 1 means that interlaminar material would separate. And this occurs over a short number of fatigue cycles. Now, when one point separates, the load will be redistributed around this point, the stresses will be higher, and collection of the separated points would form the propagating cracks. Now, if we repeat this process of the finite element simulation for the different fatigue loading condition, that would generate the respective interlaminar fatigue damage evolution curve as illustrated in this figure. We have damage versus number of load cycle at the different fatigue loading. Now, we mark here 2 lines. One is the operating damage level, which is set by the operator. And the other is the critical damage level that represents the limit of operation in order to avoid catastrophic fracture of the structure. Now, the mechanics of the interlaminar fatigue fracture process could then be described using this illustration. Now, for example, the component is operating with the stress cycle in the sequence of stress cycle 1 and then change to stress cycle 2 and followed by stress cycle number 3. So under load condition 1, the fatigue damage would initiate after accumulating N sub I cycles and evolve to point A. Now, at point A now, the change to loading condition from 1 to 2 would continue the fatigue damage evolution along this path 2. And this is copied here, along this path 2 to point B. And similarly, continuing with the load condition 3, at this damage level here, then the damage would cause the fatigue damage to evolve to or along the path 3, reaching the limit of the operating damage level. Therefore, within this cycle of the damage operating limit, the safe operation of the structure could just be monitored with the aids of artificial intelligence and the IoT. So this scenario here is actually illustrated in this framework as represented by this right-hand side loop here. Either the acquired signal is indicating no damage initiated or some damage initiated, it will be able to make the decision and supply the required information for continuous safe running of the structure. So beyond this operating cycle, human interaction is required. Then and in this module here, the decision for continued operation, it could be based on finite element simulation of the structure, accounting for the accumulated damage and the partial delamination of the interfaces that is already in the structure. And when we see this proposed framework, the framework within this IR 4.0 could easily be scaled to actually accommodate the relevant fatigue damage mechanisms and its mechanic analysis for the different applications. So with this, I would like to make the following concluding remarks. We have seen that the material constitutive and damage modeling, it forms an essential engineering module for the reliability assessment framework. And second, the validated FE simulation procedure, they are of significance in generating the material damage curve, very much needed for reliability prediction procedure. And the continuum damage mechanics approach that is embedded in the material model development, that approach enables us to simulate the deformation and the failure process in a single formulation. From a situation where there is no damage, you apply the load cycle and the same formulation can be used throughout no damage condition, initiation of damage, and all the way to catastrophic fracture of the structure. With that, I leave you with the acknowledgement page. Thank you, Dr. Moderator.
Okay, thank you very much, Professor Nasir. This kind of interesting talk about a proposed framework based on material damage model. We're waiting for a question from the participant. Please, if one have any question about this topic, this interesting topic, although in my opinion, for me myself, it's quite difficult to follow because there contain so many mathematical equation and so on. But might some of us who work in this field as well can convey the question about this topic. Please. Okay. While waiting for the question, I will deliver some question about this topic to you, Professor. As you mentioned at the previous part of this slide, you said you do an experiment and finite element modeling only for interlaminar material, or can this proposed framework can also utilize for other case occur in the metallic material and other type material as well? That's the first question. The second question, based on this framework, can it distinguish the type or the crack induced by any other effect? Yeah, not it's only because on the loading, but can it distinguish if the crack induced by inappropriate selecting of the process parameter or the process itself as well? Yeah, might that the first question from me.
Okay,
Professor. Yeah.
Let me rephrase the first question, if I got it right. We do a combination of finite element and there is a numerical procedure and experiment in order to determine the properties or characterize the materials. You see, if you consider, which is very common to engineers and metallurgists, if you consider tensile tests, yeah, you consider tensile tests, you will get load versus strain. Load you can convert into stress versus strain, and from reading the curve, you can get the properties.
Okay.
However, now in many different applications, including these carbon fiber composite laminates, if we want properties, but the properties should be valid at every material point. And when you have this configuration, what you obtain from the test is the global response of the specimen. And therefore, if you want to have the shear strength, you know that when you bend, shear stress will actually be induced at the crack tip. And at the point at which it starts to damage, start to fracture, the strength must have reached, the stress must have reached the strength. So what is the strength? It is inside. It's not in here.
Yeah.
This is the global response. So in order to know what is inside, we cannot see, we cannot put gauges, we cannot put any instrumentation inside. So what we do is we devise a finite element simulation method and we simulate. Our assumption is that if you do finite element simulation, it simulate if it is it matches the global load displacement, it means that now your modeling is correct. If your modeling is correct, then you can go to the numerical model and you can have everything, because the model will calculate all the internal variables, the stress, the strain, the damage, and so on. So it is the same for those working in microelectronics, for example. You have very tiny solder joints, and you want to know the mechanical properties. And if you do, for example, they have like what they call the shear test. But then what is the shear strength? So the shear strength is not merely the shear load at maximum divided by the area. That is only giving you a very rough estimate. So the combination of experimental and numerical give you access to what happened inside the material where the properties is much needed. So this is universal. It can be translated to many other cases. Your question number 2, if I may rephrase, can a crack forms by other than mechanical means? Yeah. majority of the crack of concern are structural crack. It means that now either it is already there due to processing, and therefore our concern is under the loading will this crack propagate? Yeah. And what is the maximum load that I can still apply to live in this crack? If the crack is there, but it is not propagating, so I can use the structure, but I need information. Yeah? So most of the time in mechanics, we are dealing with a crack that is subjected to mechanical loading. If you have environmental effects such as corrosion, it will just make things worse because you have a different phenomenon that would enhance the propagation of the cracks under what we call stress corrosion cracking. Enhance the initiation of the crack, stress corrosion cracking. What about the prediction? It's a different story. You need a different, it's different mechanisms. It's stress corrosion, corrosion induced or accelerated cracking. So it's a different mode of failure process, different equation is needed. So in other words, if we were to do simulation of physical phenomenon, we must be able to reproduce two aspects. One is the mechanics of the material, which is the response of the material to loading, usually in the form of, can you duplicate load displacement? If you can duplicate load displacement like this, that is only half the story. The other story is, can you also ensure that the same damage mechanism as occurs in reality is duplicated? So only when your mechanics and your mechanisms are both simultaneously being simulated correctly, then you can say that your model is valid. So, in short, to answer your question, crack can form under various different conditions, but maybe it's slightly out of the scope of mechanics. It can form due to the weakening of the membranes under some fluid chemical reaction and so on. But that's not the structural crack we're talking about in our scope today.
Okay, thank you, Professor. I think okay. I still have not a question in my chat room. If one has any question about this topic, please.
May I ask?
Yeah,
one question?
You can do, Pak Budi. Yeah.
My name is Dodi Budiana from Universitas Indonesia. Prof. Nasir, I want to ask, this is the test for the carbon fiber reinforced polymer, yes?
Yes.
And then, as we know, as I know, yeah, because I'm the carbon fiber is used for the strengthen the structure or other material. And then for this test, 1.2 is the thickness of one test, or if we use the other thickness, is there any some comparison if we use with the other thickness? I think 2.0 or 3. This is 1.2 millimeter. Yeah?
Yes.
Maybe that's my question.
Okay. The fundamental of the materials is telling us that properties should be independent of geometry. Yeah. Composite is a bit complicated. When you talk about carbon fiber laminates, what is the smallest unit? It is actually a ply. A ply means one layer. One layer consists of all the fibers in one direction. Yeah? That is actually the one that we say that is one layer that we would like to test. So to handle this one layer, which is much less than 1.2 millimeters, much less than that. So it's not feasible. Okay. So what we do is we said we want to have one ply. So one ply, they are taking all the 0 degrees lamina or ply, and they push together, and therefore this would actually merge together to become slightly thick single ply. But that is different from this case. This case 1.2 actually consists of many different layers. But we are not concerned about the ply. The ply is like considering the whole scope of what I presented here, because it has its own properties. It has its own constitutive equation and damage equation. But this is the only interface between the ply, which means that now I'm not talking about failure of crack across this ply, but I'm talking about failure of crack between the ply, because the interface for laminates like this is the weakest link, the interface. So the moment you have, let's say from fabrication, you have an area where there is no adhesive, you miss that, right? So there is a chance that that particular non-adhesive region will actually propagate very fast, and it will weaken the whole stiffness of the whole structure very much. So for the properties, the 1.2 millimeters is to have it significant enough or thick enough so that we can handle them. Otherwise, it's very flimsy, yeah, flimsy.
Okay, thank you. And maybe one more question. This is same case with the destruction test or this is
okay
for the testing in the lab.
Okay.
This method. Because we know for the material we can do the non-destructive test and the destructive test in the factory in application, yeah.
Okay.
Or this is the laboratory in test to check to know the damage level.
Okay. If we want to test the strength, for strength, we have to take the material, because the strength is basically loading it all the way. While you're loading it, the stress is increased. Yeah. So only at fracture it will reach its strength, and then something happen. So we need to. Otherwise, you're talking about density, for example. Those are not mechanical; those are physical.
Okay.
But we always do this thing. Once you get the property from testing in the lab, that property is actually valid for any single material point in the structure. It's not only for this piece, but also for big piece. It should be the same.
Okay, thank you.
It's similar like we're taking a representative volume by the specimen dimension.
Okay, thank you, Mr. Nasir, Mr. Prof. Nasir.
Thank you.
Okay, thank you, Pak Budi. Okay, I think because the organizer have reminded me that our time is end up. Again, thank you, Professor Nasir, for your interesting talk. You already share a knowledge about a new platform to help us in predicting the failure, the possibility, the failure of the structure before it happened, without having to do a physical test. Okay, again, thank you, Professor Nasir. Nice to have met you, although we don't have a chance to meet up directly because this pandemic. Okay, thank you very much.
Thank you.
Okay, I think I will turn the host back to the committee. Please take the host from me, please.
Okay. Next segment will be led by Dr. Eng M. Ilhamdi Rusdi. The time is yours.
Okay, thanks for the committee. Ladies and gentlemen, can you hear my voice?
Yes, sir.
Yes, sir. Okay, thank you. Yes, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
It's my great pleasure to guide us in this session. We have a special speaker who put a very big attention to mechanical research, especially human and machine interface. Let me introduce this our fabulous speaker to us. He is Professor Minoru Sasaki. Currently, he is a professor in Gifu University, Japan. Professor Minoru Sasaki was born 13 September 64 years ago. On the same day, Dr. Andus Muhammad Hatta, the Vice President of Indonesia, officially ran Universitas Andalas. He got his bachelor degree in Yamagata University on 1980. Then he got the bachelor and doctoral degree in Tohoku University on 1982 and 1985. Tohoku University located at Sendai City, Miyagi Prefecture. In his academic life, Professor Sasaki actually a professor in Gifu University, but he already built a long road in many institutions to do research and education. He started as assistant professor in Miyagi University, and he became visiting professor at California University and Georgia University. He is also a visiting professor in King Mongkut University. And finally, he has a very long story in Kenya. He already published many publications. Professor Minoru Sasaki runs some experiments in his laboratory. He already has many students from many countries. Now, personally, I know that his former student already spread around the world. Because of his dedication for engineering education in Kenya, he was awarded Doctor of Engineering honoris causa from Dedan Kimathi University of Technology. In his academic life, Professor Sasaki actually a professor in Gifu University. He also put a big attention for foreign students in Gifu University. He loved to join student activity who invite him. Today, finally, we will give the time for Professor Sasaki to give a talk. The title is Robot Control System Based on Electrooculography. Sasaki Sensei, the time is yours, please. Moderator committee can give
Professor
Sasaki as the host, so he can share the
already Dr. Ilhamdi.
Okay, thank you.
Still unmute.
Masih unmute.
Tahu ya. Enggak nemu aja loh.
Hah? Speaker.
Ini harusnya yang klik, Bu. Harusnya yang klik speakernya.
Enggak bisa, waduh.
Enggak.
Still
Ini
unmute.
tombolnya.
Sasaki, your mic still unmute. Your microphone, please. Unmute the microphone.
Nggak bisa Wak maupun dok. Oh Allah, nggak sadar ya kok harusnya telepon deh si Il kok. Iya, nggak sadar ya dah. Sedikitnya yang mengece.
Can you hear me?
Udah.
Okay.
Okay. Okay.
Okay.
So, can you see my slide?
Not yet.
Not yet. Wait.
Okay.
Okay. Yeah. Second kind introduction me, and this is my great pleasure and honor for inviting the keynote speakers. Thank you, the conference. So today's my talk about system-based engines.
Your voice is not clear, Sensei.
What is not clear? Sound?
Not clear. Please, one more.
Can you hear me?
I can, but it's too little.
Oh. Wait. Can you hear me?
I can.
Okay. So, okay. These you can see that there is 3 persons, and
It's difficult to get your voice.
Okay. And so he could not speak and he could not write and but he can communicate with
Hello? Your voice is disappear.
Disappear?
Yes. Too little.
Too little.
Yes. Too small voice.
Too small?
Okay.
Can you hear me?
I can.
Okay.
Please.
Ilhamdi.
Okay. Okay.
No.
Okay, I can hear you.
Okay.
Okay, please. So I think he's not in the room, so we must wait.
Ilhamdi, can you see this slide?
I can. Okay.
Okay.
Please.
Okay. I skipped. So I'd like first to explain about major problems faced by Japan. So in Japan's aging population combined with diminishing number of children, so decreasing in the workforce and safe and pleasant life and convenient and affluent life. So you can see, sorry, or slide in Japanese. 2005 is about workforce population is about 61%, and elderly people's population about 20%. So that means supported one elderly people by 3.0 peoples. And on the other hand, 2030 is working force population number is decreasing and about 55%. And on the other hand, elder people over 65 years old is about 30%. It means one elderly people supported by the 1.86 people. So also the new affluent newborn rate is decreasing every year. So max is about 1949. About new baby was born 2.7 million, but current less than the 1 million, and so that is very problems. So now you can see the total fertility rate is this black line shows Japanese in Japan, and yellow line shows Koreans, and so most Asian countries going down. So, but I think in Indonesia, totally fertility rate is over 2 or 3 and increasing population. That is very nice. But in Japan, not so much working force, and so new baby was born. So also government think about how to actualize the nation based on creativity in science and technologies. So setting strategic priority and enhancing mutual cooperation of research and development projects. So active effort towards international standardization activities. So this budget related to international standardizations is 1.69 billion. So enhancement of technological transfer from universities. So budget related to research and development programs. So budget related to focus 21st centuries. So it's important fuel sectors and digital consumer electronics sectors, robot sector, and health and welfare sectors, and environment, energy sectors,
nanotechnology and material sectors. So most important is the robot sector and health and welfare sectors. So it's has a huge budget. So and enhancement and compatibility of the robot industry and social needs. So this is a technological strategies. So the robot becomes something familiar to a lot of youth in life and public space. So enhancing and creative foreign generation market for industry service special environments. So strategy of acceleration of innovation and operation of robots. Introduce registration towards safety aspect. So robot is an integrative technology system. Robot technology has a big spillover effect on medium and small companies.
Yeah.
So current state and trends of assistive technology industries. So number one, possibility of assistive technology industries. So increasing needs from welfare to well-being. So increasing the quality and efficiency from activity of daily living to quality of life. In 1990, United Nations decided principles for the elderly people, self-support, participation, care, and self-fulfillment dignities. So urgent task of efficiency supply to products and service because of increasing of medical care expenditures, the elderly and welfare service for the elderly and the decreasing the population of productive age. So this is a handicapped people in Japan's percentage. So over 50% crippled people, 26.2 the mentally retired, and 9.3 is a vision impaired, and something like that. So this is a requirement of welfare equipment. First is user friendliness. Second is safety. Third is cheap. Fourth is simple. Fifth is after sales service. So I would like to ask about potential of biopotential signal interface to welfare equipments. So qualitative evaluation method of human diversity. How to communicate between the machine and the human. And machine and robot has no sensor about communicate between humans. So that is also problems. So how to realize the borderless world, disabled and able persons. How to make an objective state estimation of the humans. So merit of physiological bioinstrumentations. First is objectivity, second is quantifications, third is real-time operations, fourth is continuity, fifth is non-verbal, and sixth is vital function. So can we estimate and analyze the emotion of human by using the biopotential signals? So require technology of analysis and evaluations. So first is instrumentations, include electrodes, amplifiers, and frequency, and AD converters. Next is the signal processing method, analysis, spectral analysis, FFTs analysis, and wavelet analysis, and so on. So analysis, feature measurement, statics analysis, multivariable analysis, etc. Also, it has a huge database. So biopotential signals include, for example, EOZ, EEGs, EMG, and the ECG, and neurological potentials. Sorry. So I'd like to show you some example of our previous research about locomotion robot control using biopotential signals. We use simple biopotential measurement systems like headband includes the sensors, electrodes, and we can detect EMG, EOG, and EEG signals. So this system is easy to put on and take off. And so this is analysis of biopotential signals. We use a neural network for recognition of signals. So also experimental system is operator attach the sensor and send the data to the PC, and PC send to the robot control signal to, and then robot receive the control command. So this is example of experiment. Sorry, small robot is go forward and go backward, turn right and turn left. So also, I'd like to express emotion estimation by using brain waves. So this is a experience setup. This is a sensor helmet, and this is the analog digital conversion box. And this is a processor box, include the data filter, and finally the data to the PCs. So this is imagination and real data. So this is the colored map shows the imagine case of right hand moving. So this figure shows real right hand data, the brainwave mapping. So this is also imagine left hand and real left hand motions, and next real right toe moving, and imagine right toe moving, and also imagine left toe moving and real left toe motions. So you can see the color difference. Blue shows not active, and green shows a bit more active than blue ones, and red shows more active than others. And you can see the mapping difference, and some part is colored red, but other case is blue and greens. So if we can identify these mapping difference, we can understand the human operators operations. So this is a function of cerebral cortex and sensory mapping and motor mapping. So you can see in case of motor cortex, huge areas shows face, but also hand area is big, but very small area related to the legs. So that means so we can operate, think about hand operation and face operation, but we are usually walking, but at this time we are not think about how to operate my legs and something like that. So this is a aspect part of the brains, right legs, left legs, and right hand, left hand. So that is a result of motion estimations rate, almost over the 70%, 80%, and 90%. So this is a motion estimated experiment. If robot detected the operator's motions and robot moving same as operators. Oops, sorry. So you can see the same motion of robot and operators. So also the robot control needs not limited on-off control, but servo controls. So this is only 1 degree of right and left motions related to the eye movement. You can see this. So, but it's a original point is difficult to match, and some difference between the eyes motion and some motors motions. So this is not limited 1 degree, it's extend to 2 degree systems. It says 1 to 3 and 1 grand, and please take care. So, and also the proposed EOG attachment method and conventional method attached by electrodes, but it's every time change to the accuracy of the attachment point. But if making the like mask, and so after that electrode position is fixed, and we can get data for the stabilized data. So this is if EOZ used for robot operation, we can distinguish two methods. One is a gaze estimation control method. The other is gaze direction control method. So gaze estimation controls are developed by the Ilhamdi, Dr. Ilhamdi. He remains a great effort for this research. And so from EOGs, we estimated the eye position, and manipulators move to that estimated positions. And so also, but if use EOGs and only one plane motions, but if you change the side view and top views, we can use 3D realize of 3D motions. And also gaze direction control step by step by Amri, my previous doctor course students. He realized step by step. But think about for robot control, we need one more input for control the robot hand or something. And we utilize that to EMG sensor on the face, and we detect the EMG for controlling the robot hand. And so also we should improve the transformation method. You can remember, and this method is has a skew angle for related to the 4 sensors. But so we Ilhamdi developed a new method of transformation matrix to this compensate skew angles, and then finally the real coordination. Right, this is a improved method equation for transformations. So also this is a CD player control systems story in Japanese. You can see the 3 electrodes at the forehead. Sorry, limited time, I'd like to skip this. So also the also 3D coordinate positioning operation systems. By potential signals pointed out the desired position and move to the robot. So, also end of manipulators control via EOGs and upside, up and down, and right and left. So also the this is a two-dimensional control via EOGs. So EOG from estimated desired position and move to the manipulator to the operator's desired positions. So also this is a previous Ilhamdi's experiment. He extended to two-dimensional to three-dimensionals from side view and top views. So also this is Omni's experiment. So step by step and down and down and down. And T-spite EMG related to the hand grasping and then up and up. And move to left and left and then put the point. So also this is a EMG control experiment. Attach the electrode to the hand and estimated arm motion to same motion to view the monitors. If we place this monitor to the real robot, and we can control the robot hand. So I would like to make a conclusion of my talk. So we can operate some machines and robots by using biopotential signals, especially the EOGs, from on-off control to sub-controls and on-demand controls. So how to distinguish malfunctions? So biopotential signals means we can usually come out these signals, and we should distinguish malfunctions. So we need a more basic knowledge about the biopotential signals and human motions and emotions. So future work is from implicit knowledge to cognitive knowledge. So we should apply to life support and well-being system and also training system for artisans and transmit traditional to post studies. So also Ilhamdi applied to this kind of biopotential signals to famous badminton player and beginners badminton players, and then how to learn from beginner to expert or something. So I would like to ask the final question. What's next from robot to cyborg? This is a famous movie of Firefox for robot airplanes, and this is a Japanese anime Cyborg 009, and so also RoboCop, and my girlfriend is Cyborg is Japanese movies. Thank you for your attention, and sorry, a lot of trouble happens. So, thank you, Hamdi.
Thank you, Professor Sasaki. Very interesting talk, and we know that Japan face a struggle condition with aging society, and this situation happened also to the ASEAN country, but in Indonesia, at this time, we still have enough new baby born, but we don't know next time. I think almost all country will find the same situation. So biopotential is one of the another solution to help people with disable condition. So especially in this situation where people cannot touch each other to operate machine because of pandemic COVID-19, for sure that we need alternative methods to operate machine. So we will give a chance for participant if maybe someone has want to ask or discussion. We please participant in the room. We have more than 200 participants right now. If someone want to ask Professor Sasaki, please just active your speaker, your mic.
Morning, sir.
Good morning.
Yes, please.
Yeah.
Please your name and institution.
Yeah. Good morning, Pak Ilham. My name is Hasbi Fadli. My honor to meet you in this conference. Good morning, Mr. Minoru. I'm very amazed with this technology, since it will be appropriate solution for helping disabled or other solution, other problem. My question is, what is about the safety of this technology for human? I saw in the video there was tools that stick in human head to move a robot or something. Is there electric signal that can impair the human head if applied in long duration?
So that is a very important point. So think about now the most of robots for industry used, and not yet service robot, and that is low problems. So at first we should make liability law or something, right? And how to give the responsibility if happens accident or something. So same as autonomous car control or something. So after the making the legal problem, then we should also for example, the industrial robot is over the motor's output. So if personal use service robot is we now the limited output powers less than, for example, 30 watt. If robot touch the human beings or something, at this time no accident happens. It's soft touch or something. So you can see the Ilham's experiment. That robot is flexible. It's we think about so service robot or welfare robot. It needs some robot is not rigid but flexibility.
Okay.
Is that okay?
Okay, okay. I ever saw the Pak Ilham innovation for your chair. Okay, thank you.
Thank you, Bapak Hasbi Fadli from Universitas Indonesia, University of Indonesia.
Yes, Pak.
Okay, please.
I have question. I have question.
Please, Bapak Firman Ridwan, please.
Yes. Thank you for my opportunity to ask question. This research is very interesting actually. And we, as I saw in the video, when we control our mind, can we translate, like, you know, translating the mind from, you know, moving left and right? Is it possible, like, you know, instead of changing, moving the video, we translate into sentence or word? For example, like robot arm, when we're thinking about moving the object from one to another, and then we translate into some, you know, sentences instead. Means this very important for, you know, someone who got, for example, like who got stroke disease, and very difficult to saying something and just by thinking and translate into the sentence, and we know other people knows that what the victim thinking about, something like that.
So
can you catch my question?
Yes, and so current situation of research biopotential signals has not so accuracies. So we need a more research about. I said to you the from on-off control to the servo control. Servo control needs a more information to, so how fast or how long or something like that. It's need a more information. We can we should pick more information about for example brainwave and the EOG and the EMG, but EOG has a lot of possibility for more accuracy than other biopotential signals. So, for example, we sorry, we showed the result of two-dimensional control. It has a good accuracy, but a lot still lack of accuracy. We need more research for that situations. Is that
Okay.
right? Okay.
So the Bapak Firman Ridwan asked, instead of controlling a robot using our brain, is it possible to transfer our brain signal into text? So can we give information to people from our brain? So if we are thinking, the signal convert to text instead of moving robot.
So still a lot of people doing research about such kind of things. Not that realize such kind of situations, we should more research about such kind of things. Is that okay?
Thanks.
And also the another problem is using brain waves. Brain waves means it depends on individualities. So some people are different from their background. This time the brain waves different outcomes, and that is problems. So yeah. So if we read the same novels, but people think about the different feeling and the different emotions, that is problems also.
Okay. Because of time, we will give the last chance for participant. If you want to ask question or Harrison,
I have one.
I saw you. Harrison. Special guest from Kenya. Please ask your professor.
Okay, I just came in midway when Professor Saki was presenting. So, but it's the topic, I think you are an expert in under the professor. So I'll not make a comment now. I'll just maybe join and listen. I don't know if the video is clear. I'm not very sure. I'm in office now.
Thank you for attending.
Thank you.
Okay, please another. Thank you, Harrison.
Thank you, Trihan.
Please,
I have one question, moderator.
Please, Prof. Please.
Yeah. Prof. Sasaki.
Yes.
I think you are addressing very interesting global issues on aging. And you have highlighted the human interaction to be explored, yeah. And in doing this, it requires, among other things, a lot of things. Among other things, it requires, for example, programming skill, graphical user interfacing. So now, my question is that, in order to address these, what is the way forward in education? For example, if you could highlight in Japan, is there any changes or upgrade of the curriculums to kind of highlight the way forward along these lines?
Yeah, it's so not yet going ahead, but our laboratory tried to do STEM education, science, technology, and mathematical art, and something. It's so maybe human beings education started to the making something, and but making something needs a lot of technology field. For example, mechanical, electrical, programming, and something like that, and also art and mathematics. And if through this education we can naturally get such kind of performance, but it takes a long time, and so also technological education needs a budget and money, and so how to keep that government should support this kind of education for next generation of technologies. If stopped and something wrong, we can not solve the population increasing elderly people, and also coronavirus and a lot of things. But if we have the creativity and the new technologies, and maybe we will be able to solve this kind of problem. Is that okay for?
It's good. It's okay. It's good. It's okay.
Okay.
Thank you.
Thank you, Professor Nasir Tamin, one of our keynote speaker. Okay, Professor Sasaki Sensei. So, because of time, it's already 10 in Padang City now. So, thank you very much for your presentation. It's very nice and very interesting. We hope I'm sure the participant will get many knowledge, and I hope. I know that you are open for this discussion outside this room for other. So thank you very much, and we will give the time for the committee again. Please, committee, I hand over this mic for you. Thank you, Sasaki Sensei.
I appreciate. Thank you.
Please, committee. Please, committee.
Okay. The next agenda is we're gonna have a lunch break until 13 and 10. And now we'll show the profile video of Engineering Faculty Department.
Penumpang Kapal Rupa selamat datang di Bandara Udara Internasional Minangkabau di Padang Pariaman. Demi keselamatan Anda, tetaplah duduk sampai pesawat ini benar-benar berhenti dengan sempurna dalam putaran kenakan sabuk pengaman telah dipadamkan.
Malien rang hati dina hati indah karusua ayam dan lape ayam dan lape mandaki jalan pandai sike manurun jalan dari tarung dina hati ndak kenal pe awak lagi cua ayam dan lape Jagalah kamu Rana malingkan Gunung singgalan Pendek Laika manjaga Oh mandeh kandu Tolong jodoh Entah pamilo Pendek Kita basuh Jaga dia buang Kok lain kamu Bila masuk Kita basuh Sadang no are Tali hijau buku Bakare rotan Kini jadinya Jika taraga Yona basuh Di dalam nyanyi Pendek Denai pasangan Jika taraga Mandega Di dalam mimpi Pendek Kita bertemu Oh mandeh kandu Tolong jodoh Entah pabilo Pendek Kita basuh Takkan dia Kok lagi kamu Bila masuknya Kita basuh Sadang nungare Tali hijau buku Bakare rotan Kini jadinya Jika taraga Yona
Itu berasa kan adalah
Ya.
bukan ini kita
Ya, langit cenderungan ya.
kalau bangunannya kamu kontrol langsung app
ndak kunjung tiba. Lah tiba pulo kapal balabu, udah dan nanti di Teluk Bayuan ndak kunjung tiba. Udah pulanglah udah.
Ladies and gentlemen, back again with us. Let's continue our next agenda with the fourth keynote speaker, led by Aulia PhD as moderator. Floor is yours. I'm sorry for mistake. Sorry for our mistake. The next agenda. Moderator, floor is yours.
Assalamualaikum warahmatullahi wabarakatuh. Excuse me, can you hear my sound?
Yes.
Yes. For the first time, thank you very much for Professor Masami Furuichi from Kanazawa University, who already attending our conference, and also for all participants joining this online conference in this session. For the first time, I will introduce for all of all about Professor Masami Furuichi Sensei, who will be present about his research. Masami Furuichi Sensei is a full professor of Faculty of Geoscience and Civil Engineering, Institute of Science and Engineering in Kanazawa University, Japan. In July 28, he was appointed to an honorary professor of Faculty of Environmental Management, Princess of Songkhla University, Thailand, for his large contribution to research and education. He is the head of Atmospheric Environment and Pollution Control Engineering Laboratory, Kanazawa University, who received a doctor's degree of engineering in chemical engineering from Nagoya University, Japan in 1990. His research are currently focused on the instrumentation for the evaluation of aerosol nanoparticles, or PM.1, and their application to environmental monitoring, source apportionment, and personal exposure. From 2030, as one of the founders, he has been organizing the East Asia Nanoparticle Monitoring Network, we can say EA NanoNet, for the monitoring and characterization of PM.1 in East Asia. Recent research interests are also on PM emission from biomass burning related to agriculture and their characteristics, online characterization of bioaerosol, relation between environment and human behaviors, and online networking of PM.1 monitoring. He also an editorial board member of Aerosol and Air Quality Research from 2008. Masami Furuichi Sensei also, we already make collaboration research with our faculty engineering, Universitas Andalas, and this instrument already used to monitor the quality of air pollution in Indonesia, especially about forest fire. Maybe we can discuss more about this topic with Masami Furuichi Sensei. And in this session, we have two sessions. First session is presentation from Masami Furuichi Sensei, and the second session of discussions. For this discussion, there are two types of discussion. As explained in the beginning, anyone can ask the questions anytime by chatting room. Please write your question there, and I will read the question to our speaker. And the second one is the participant can give a question directly in the discussion session by unmute your speaker, and then you can make a question directly. We continue to our sessions, presentation. For the presentation, Professor Masami Furuichi, time is yours. Okay.
Thank you very much for the kind
You're welcome.
Zul-san. Okay, and okay. Selamat siang. Nama saya Masami Furuichi. Saya sangat senang hari ini berbicara tentang PM0.1. So it is my great honor to have such a precious opportunity to introduce our research on PM0.1 to the distinguished who participating to this international conference. And actually, this is the first time to join the international conference online. And I'm not quite sure if I can do well, but let me start. Okay, then I need to share the slide. Okay, let me start. Can you see the slides?
Yes, it's clear.
Okay. Okay. So my talk is on the research on the nanoparticles, and we have some network for the measurement of PM0.1 in this area of the East Asia, as well as Southeast Asia. So today's contents of my talk is, let me start from there, some short introduction about Kanazawa and Kanagawa University, because many of them may not know about Kanazawa, and why nanoparticles. We are discussing about the PM0.1, why nanoparticles, and what is EA nanonet, and what for, and measurement of PM0.1, why do we use an air sampler, and what are we doing now, and examples of achievement, and activity of young researchers and students, future direction, and conclusion. So let me start from where Kanazawa is. So the Kanazawa is here is Tokyo, Kyoto, located here, located Sea of Japan side, and recently, already more than 4 years, I don't know. The Kanazawa is now connected to Tokyo by Shinkansen. The fastest time is, the shortest time is 2 hours and 30 minutes from Tokyo. And also not far from Kyoto and Osaka, and like 2 hours. And Kanagawa University has 3 main colleges: the human and social sciences, and science and engineering, and medical and pharmaceutical and health sciences. Recently, next year, we will build another college on some fusion of the human and social science and the science and engineering, and as well as, anyway, these three different categories will be merged into some different college. So Kanazawa is rather famous from the traditional Japanese culture, and one of the famous sightseeing spot in Japan. But recently, much less tourists from outside because of the COVID-19 problem. And these are typical pictures from Kanazawa. There are the old castle, the original building, and the famous garden called as the Kenrokuen. And depending on the season, this is a sakura season in April, and this is the winter season. So both seasons we can enjoy the beautiful scenery. Also, I don't like to go to the Kenrokuen garden in the winter season. And the Kanazawa University is a famous place for the very large number of the cherry trees. And Kanazawa is also very famous from the very delicious sushi because Kanazawa is located just beside the sea of Japan side. Okay, let me start from the research, Why PM 0.1, particles smaller than 100 nanometer? So this figure shows describe the size distribution of the particles in atmosphere. But the two different expression. The bottom side is the mass basis of particles, and the top side is the number basis. So let's start from the mass basis. So typically, the size distribution is described as bimodal, two peaks in a size distribution. One is something like a 5 micrometer in a peak, and another peak is located less than 1 micrometer, typically the 0.5 micrometer. So each peak corresponds to the emission from the natural sources, the coarse mode, and like dust from the ground surface, or sea salt, or pollens. Anyway, many of them from the natural sources, maybe sometimes from the volcano. And smaller one is many of them are from some burning of the fossil fuel for the human activity. It means this particle contains more hazardous chemicals, very risky chemical component. But peak size is something like 0.5 to 1 micrometer. Okay, let's move to other number basis. So it is clear, nothing around micrometer order. More than 90% of the particles is in size smaller than 0.1 micrometer. It means the particles in the air is almost the particles smaller than 0.1 micrometer in the meaning of the number concentration. This is very important. Okay? So that this small particle contains more hazardous chemical, and number concentration itself, the number of the particle can be the trigger of some health influences. So the health influence is not only from the mass of the hazardous chemical, but also from some initiation of the closely related to the number of the particles. And another thing is that these small particles can penetrate deeply inside the lung system. So this 0.1, 1, and 10 and 100 micrometer. So the alveolar region, this is the deepest part of the lung system where some chemicals or some sort of gases are exchanged between the blood. So let's see the fraction of these particles of smaller than 0.1 micrometer, the largest deposition in the alveolar region. So it means that the hazardous chemical in these size of particles can easily be dissolved into the blood and spread into the human body. It means the more risky particles. So from this reason, so PM 0.1, the particles smaller than 100 nanometer is important. So to know about the situation of this small PM 0.1 particles, we established the EN NanoNet, East Asian Nanoparticle Monitoring Network. It was established in 2013. It's consisting of, I think that this one, 12, I think 11 countries, and located in North and Southeast Asia, and 24 universities, 5 institutes, 1 governmental agency, and 1 company. And based on the researchers' interest and volunteer, and the 2 leaders, Japan, I from Canada University, and Professor Teka Sakuru. He's my friend from the Prince of Songkran University in Thailand, and we also have the 3 coordinators. And common tool is an air sampler for PM 0.1 that was developed and provided by Kanazawa University. And we have been supported by the several research grants, mainly from the JSPS. And also we are now trying applying the quadruple program, JSPS, and other research funds as well. And each year, every year we had a workshop to share information between the members. It was started from 2014, and this year will be held in coming December by online. And this slide shows the map of the distribution of the participating member. So it is members are from Northeast and Southeast Asia, and what we call it as East Asia. So the biggest group is from Thailand, and the second is Japan, and recently 4 universities from Indonesia are joining. And the most recent member is from I think Myanmar, Mandalay and Yangon Technology of University. And between us, the picture shows the common tool between the members. These kind of tools are shared and distributed from the Canada University. And this is some detailed map for this area of the Southeast Asia. And you can see there are many members are distributed in this area. And 1, 2, 3, 4, Bandung University. Oh, sorry, I think I need to add another member from Indonesia, I think. Okay, yeah. So now we are expanding our network to outside the East Asia, like the Africa. We have 2 members from Nigeria, and trying to find a member from India and also from Philippines. And we have a collaborator from the University of Vienna. We are working together on the instrumentation of the air zone measurement so far. So what is the purpose of the EN NanoNet? So we want to know the status of PM0.1 in East Asia region, and what is the local emission sources PM0.1. And there should be some transboundary influences and health risk of ambient PM0.1. And the biomass burning is one of the most important emission sources of the PM0.1, include as well as other particles. So what we want to try to do is to obtain the emission inventory of the biomass burning, various type of the biomass fuel, not fuel, but various type of agricultural residue and the trees. And we are also trying to develop the new PM0.1 instrument for the new PM0.1 measurement. And of course, the most important one is to share knowledge on PM0.1. And through these activities, we educate the student and young researchers. So how are we measuring the PM0.1? So we developing now the 2 different type of tools. The one is the air sampler that collect the particles on the filter. Another one is a sensor to detect the PM0.1 online. So, but at this moment, measure tool is the air sampler. But both type of the technology use the common original technology developed in Canada University, what we call the inertial filter. Oh, sorry, I should use the pointer. Inertial filter technology. The air filter is used to remove the particle, to clean the air normally. But inertial filter is used to separate the particles at some size. How can we do this? Normally, the air filter, the airflow velocity through the air filter is like a 10 centimeter or 15 centimeter, maybe the 30 centimeter, maybe the largest. But we use a much larger filtration velocity, like a 20 30 meter per second. By this, we can increase the inertial effect acting on the particle, even the particles like 100 nanometers, the size of small particle. This particle is normally collected by Brownian diffusion, but even for this size range of particles, we separate them using either inertial effect. So the normal air filtration curve, separation curve for air filter is like this, U-shaped, but inertial filter technology, it modified like this by increasing the inertial effect. So based on this technology, this is a typical inertial filter, the metal fiber, metal stainless steel fiber, like this size of diameter. Putting this fiber to the circular nozzle and allow the air flow through this nozzle to separate the particles. So we have been developing the several type of the air sampler based on the inertial filter technology. This is the cascade air sampler that can separate the particle into some stages like a PM10, 2.5, 1.5, and PM0.1 at the flow rate of 40 liters per minute. This is the most important common tool between the EA nanonet members. And we also developed the high volume air flow rate of your sampler for the nanoparticles. This is like a 400 liters per minute. And this is used to collect the nanoparticles in a very shortly, a short time period to discuss about time fluctuation of the chemical component in the nanoparticles. And we also developed a smaller flow rate of the instrument. It's a 4 or 5 liters per minute. The main purpose of this instrument is to collect the particle in the human breathing zone. Yeah. And this can be operated by a battery pump and carry, and you can walk together. We can walk anywhere where wearing this instrument like this. This is workers in the nanomaterial production factory. So why do we use the air sampler? Because there are many instruments to measure the nanoparticle in the air. The answer is simple. These instruments are too expensive. The cost problem. Our air sampler is cheap. That is very important when we want to share this instrument between many members. The number is important now to know other large number the air pollution information on air pollution at many locations. This is a recent trend. Then we can discuss about something like aerial behavior of the atmospheric environment. So the number is important. To do it, the chip is very important. And to discuss about the emission sources, for example, we need to analyze the chemical component. To do that, we need to have the particles on the filter at this moment. So this is the reason why we use air sampler-based technology. And what are we doing now? That example of the ongoing activity. And so evaluation PM0.1, this is the main purpose of our network, to present status characteristics and comparison between site, influence of events, Southeast Asia, the forest fire in northern Thailand, and forest fire in Indonesia, Northeast Asia, dust storm from China, and to prepare some emission inventory of PM0.1. And now we are developing the simple and low-cost PM0.1 sensor for the IoT network. This is also a very important issue. So let me show some example. Because I don't have enough time to explain in detail, just show shortly. This is PM0.1 mass concentration obtained through the 3 different campaigns conducted by EN NanoNet 2016, 17, 18. So the left-hand side, there are data from Japan, and right-hand side are mainly from the Southeast Asia. Can see the big difference between Japan and Southeast Asia. These data are denoted by this arrow are from the Indonesia. So the Indonesia situation about the PM0.1 concentration is rather similar to other countries in Southeast Asia. And these data are not published yet, just submitted to now in the under reviewing of the journal. Data from Indonesia, data collected by Medan city in North Sumatra Island. And the first one is the PM concentration, PM 2.5 and PM 10. And we got a data from the 4 different locations in the Medan city area, like an industrial area and roadside and volcano area, like the kind of rural area. So comparing to the WHO guideline, only the volcano area, the rural area, can we say it is in kind of still outside of the WHO guideline, but according to the Indonesian National Air Quality Standard, so volcano area is okay, but the other location is still outside, out of the National Air Quality Standard of Indonesia. Okay, this is the kind of situation in the PM in Indonesia. And the right-hand side is from the chemical component of the chemical component in the PM 0.1 particle. So the carbon component in PM 0.1, and the x-axis is the elemental carbon concentration. Y-axis is the ratio between the organic carbon to ratio of organic carbon to elemental carbon. So the blue trend line indicate the data from Korea and Japan, and the data inside a red circle the data from the Southeast Asia, and colored one is from Indonesia. So the tendency, the more EC concentration, elemental carbon, and less OC fraction. And the tendency may be slightly different from the northeast side area of the Asia. And many of them are, I cannot show the data on that, it is too much detail, so that many of them are from other traffic. It is clear the influence of the traffic in this area. So this is not a PM 0.1, but the PM 2.5, but the data shows the relation between the estimated emitted amount from the open burning of the agricultural residue in Thailand. The C is the Nakhon Sawan in Thailand, located almost center part of the Thailand. And the right-hand side figure is Khon Kaen, the northeastern side of Thailand. So the blue bar graph denote the emitted amount, estimated emitted amount from the agricultural residue burning, crops, different crops by crops, the sugarcane, cassava, corn, and rice, fire as well. So, and the black plots denote the data from the PCD, Pollution Control Department station in Thailand. So it is clear, there is a clear correlation between the emitted amount from the open burning, the agricultural residue, and the particle mass concentration in this area. This is a very important findings. And I can say that basically the PM concentration in Thailand is dominated by the emission from the open burning, including the forest fire. The situation may be similar in Indonesia, but we are now trying to find the evidences. Okay, so there are some activity in the EN Nanonet. Every year from 2014, we have a workshop for Thailand and Japan. And the 7th EN Nanonet was scheduled originally. Oh, this is not. This originally scheduled, but was changed to the online meeting in December. Okay. The young researchers are joining this workshop like this. And our direction is, as I already explained, a simple, low-cost and robust PM0.1 sensor. This is very important for the IoT technology. And also, we will keep on using the low-cost and robust PM0.1 air sampler for the detailed discussion on emission sources and health risk. And we are trying to build a dense network by combination of about 2 types of instruments. So let me conclude. So we can collaborate through simple and low-cost technology with the requirement of the simple skill, but for the cutting edge and useful output. Such an approach can be a platform not only for the collaboration between mature researchers, but also for the education of the young researcher and student. And EN Nanonet and Canada University always welcome partners from Asia Pacific countries. So this is not the member in the 2019 that we have now the 3 PhD students from Indonesia. So far we have many students from Thailand, Cambodia, and Indonesia as well. This student from Japan. Okay, thank you very much for your kind attention. And terima kasih banyak.
Okay.
Yep.
Thank you very much, Professor Fuji Sensei. It's very nice presentation, and I know that topic about PM 0.1 is a new topic in Indonesia. I think we don't have an expert about this topic. And we also say thank you for Masami Fuji Sensei who accept our students to study there. We hope the student can come back to Indonesia and we'll develop this topic research, because in Indonesia about air pollution is a common from the forest fire or from the also we have cement industry, the location near with the university housings, and we can I write about this topic that the risk for our health is very high because the large fraction of nanoparticle in the air, and it can reach our deepest part of our lung. So this is very interesting for research. And I also note the second one is there is a chance to collaborate and to join the EA Nanonet from university from Indonesia. In Sumatra, there are 4 universities already joined, and for the participants from other university can join with this collaboration research. It will be benefits for our career, our research, and our environmental problems. And we have 15 minutes more for discussions. For the participants, please, if you have questions, just unmute your speaker and speak directly. Okay, I'm waiting for the questions. But there are one question in the chatting room. I will read the question and please Fuji Sensei to answers. Question from Fajar Gumbira, Doctor Engineering, Dr. Fajar Gumbira. The question is, Professor Furuchi, thank you very much for your very nice presentation regarding the nano sampler air sampler for PM.1. that was developed in your laboratory, is there any influence of its particle size, separation, performance, if we use it in humid environment, like in coastal area in Indonesia? Thank you very much.
Okay. Depend on the chemical component of these particles, but if they are hygroscopic particles, yeah, truly influenced. And because we don't manage either the humidity or temperature, atmosphere inside the air sampler, this kind of influence can be happen. Not only for this type of air sampler, but also in other type of samplers. So, but it's very hard to say how it is serious.
Oh, I see.
Yeah.
So where is the main problem? The main problem is the sampling time or the result of filtration or the result of particulate matter that we get from that sample.
Depend on the level of the humidity. I think that, for example, we had some experience to collect the particle in the flue gas, smoke from the wood burning from burn in the oven. A lot of humidity, moisture contained. So in this case, we have some problem about some wetting of the filter. And for the stages, for the particle larger than PM 0.5 in our air sampler, that is just the filter on the plate, not filtrate through, but the last stage for the PM 0.1, just there is a filtration. So if the filter is wet, has some problem. And the key technology of inertial filter, it may also it may be also influenced by the humidity. Separation performance will be shifted to maybe either, I don't know. I didn't check it. It is also the interesting issue, but didn't check it. And they easy to be clogged based on my experience under such a condition of the very high level of the moisture content. But I didn't check the separation size change, like from the 100 nanometer to 150 nanometer or even lower. But the pressure drop increased faster than that for the dry air, I think.
I see. Okay. Maybe the question Dr. Fajar Gumira already listens the answer from Furuchi Sensei, and we continue for the other participants. Please, if any participant want to give a question, please unmute your mic and give the question directly. Maybe I will want to know more about this particle. Does this instrument can be used for biological agent, like for virus, for microbes, or for bacteria?
Oh, you mean what do you mean? Yeah. And your question is if you can do some biological analysis from the samples?
Yes, yes.
Yes, I think, yeah, that is one of the things we may try, but we should choose the type of the filter for better discussion about microbes or some biological analysis. The filter now we're using is a quartz fibrous filters because we want to analyze the carbonous component. For this analysis, we need such a quartz type of filter, quartz fibrous filter. But for the biological analysis, you should use some other type of filter, like I don't know, cellulose filter or other type anyway. If you use this type of filter, I think no problem. Just wash them out from the filter and then analyze along the same protocol for the liquid sample, I think.
Okay, the interesting one is the instrument made by Kanazawa University and in the laboratory of Masami Furuchi Sensei. It's very interesting because can make instrument is very high, very useful for the research. And then there is another question in the chat room from Professor, from Dr. Zaini. The question is, beside to human health, does PM 0.1 reduce the dielectric strength of insulator? This is about electrical engineering. Does Furuchi Sensei mention the question? I replay the question.
The electric.
Okay, I will reply the question.
What is where can we find this problem? The insulator.
Yeah, insulator.
So the PM 0.1 is where in the PM 0.1 in this case? So that's on the surface. On the surface of the insulator.
In the surface, I don't understand also. This is a topic about electrical engineering. The question is, I will replay the question again. Does PM 0.1 reduce dielectric strength of insulator?
Some coating of the very ultrafine particles on the surface of the insulator. If so, I'm not so familiar with it.
Oh, I see. Yeah. This is a different topic, or I don't know what is the relation also. Maybe Dr. Zaini can explain more by speak. Please unmute your speaker.
Okay.
Give clear.
My question is, we have a transmission line to deliver power from power generation to customer. Power is widely used where the base is supported by insulator to the tower. So is any side effect from PM to the electric strength of the insulator in the tower? Do you know what I mean?
Oh, I mean the PM 0.1 in the environment, in the
environment, in the atmosphere.
In the atmosphere, I see.
Yeah. That affects the surface of insulator located in the tower.
The surface of insulator in the tower, electrical tower.
It's difficult to answer for me. Some are
maybe
the electric characteristic, right?
Okay. Yeah, yes, electrical.
So not only by the PM 0.1, because in such case, other size of particle also deposit, right?
Deposit, yes, I think so.
Deposit, but maybe this particle already has some influence to the dielectric strength of the insulator. It's something like electrostatic precipitator, I guess. And reduce the dielectricity normally, the particle layer, the particle deposit no filter, but I don't know about the influence of the size of particles, like PM 0.1. Sorry, it's hard to answer for me.
Maybe we need research about that to answer the question.
Oh, yeah.
I think so. Okay. so many questions that need to be solved, but to answer this, we need deep research about that and correlation between one topic with the other research about air pollution and electrical engineering. This is interesting collaborations. Okay, we still have 5 minutes. There is one question more for Kanazawa University. This is our student, doctoral student, Dendi Adi Saputra. The question is, yes, thank you very much for your nice presentation, Professor Furuchi. Continuing the question from Dr. Fajar Gumira, is it possible to infuse the desiccant material into your filter material to solve the humidity problem in your filter? Okay, is it possible?
Yeah, for the case like the sampling of the smoke from some burning, atmosphere burning, for example. So normally we use the technology for the dilution of the air, not directly sample the flue gas from the biomass burning, for example, diluted from some dry gas, the clean air, diluted by clean air to reduce the humidity. And that is for the sampling for the kind of source sampling, but in your case, some ambient sampling, but a high humidity because the sampling site is located very near to the sea. And what I'm thinking is you prepare some instrument to supply the clean and dry air to dilute the humid air, but this reduce the particle number and mass concentration. So depending on the particle concentration, it should be too much diluted. So in that case, that is another idea that is to use the so-called diffusion dryer. Diffusion dryer is the instrument consisting of, for example, the silica gel packed as a column and like a cylindrical column, inside of which the circular hole, circular tube, circular mesh tube, I had to explain in English, tube made by wire mesh, for example, it penetrates through the packed column of the silica gel. Then we let air flow through this tube slowly, or to dry the air out, to remove the humidity. So the water vapor absorbed, diffused to the silica gel, and the air will be dried when it leaves this diffusion dryer. But particles is much larger than the molecular of the water molecule. They don't, of course, some also deposit in the silica gel, but much less amount comparing to the water molecule. So the particles, most of the particles still in the air, but air is dry. This kind of instrument is a kind of usual technology to dry the air out before the sampling. Another one is the heating up the air to reduce the relative humidity. But in this case, there are some volatile, semi-volatile particles that can be evaporated under the elevated temperature will disappear too. So it's depend on the situation, but we can choose some technology like I explained now, 3 different types, mixed with dry and clean air, or use the diffusion dryer, or heating it up before the sampling to spread some material, desiccant material into the filter. I think I think the amount of the discount, it may not be enough because of the large amount of air flows through the filter, but filter surface itself is not much to absorb the water vapor on it. Can it be an answer?
Okay, Dendi.
Thank you very much, Sensei. It's a nice explanation. Arigatou gozaimasu.
Bye.
Okay, thank you very much for the last question from Dendi Adi Saputra. We hope you can graduate from your doctoral program soon and come back to Indonesia. So many years can continue. Also, thank you very much for Professor Masami Furuichi. And don't forget about the invitation to join the EA NanoNet with Masami Furuichi Sensei. And the university can apply for the association and to develop the research about nanoparticle in Indonesia. And this is very interesting research and good change for collaborations in our research. Because the time is very limited, we now is already 2 o'clock p.m. We have to stop our. We have to finish this session, and we also say thank you very much for nice presentation for Furuichi Sensei, and also for all participants and all the participants who give the questions. And for the next session, I will give the time to the moderator. Please, the committee. Time is yours now.
Terima kasih, Madam.
Terima kasih, Sensei.
Arigatou gozaimashita.
Arigatou gozaimashita.
Arigatou gozaimashita.
Well, ladies and gentlemen, this is the last session with the speaker from United Kingdom. Let's continue our last agenda with the 5th keynote speaker, led by Aulia PhD as the moderator. The time is yours.
Yeah, thank you very much, the host. Can you hear my voice clearly?
Yes.
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 Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, or still in the morning, with Dr. Bernard. Let me introduce myself first. My name is Aulia. I am a lecturer in the Electrical Engineering Department, Universitas Andalas. I was in UK in 1998 for doing my master's degree in Manchester University. At that time called UMIS. Then I finished my PhD in UTM Malaysia in 2016. Okay, I'd like to welcome Dr. Bernardi Prangono. Let me read the summary of his. Dr. Bernardi Prangono is currently a senior lecturer in computer network engineering at Sheffield Hallam University, UK. His research focused on cybersecurity for critical infrastructure, such as smart grid. He also has interest in cloud computing, optical networking, and green ICT. He has previously held position at the Glasgow Caledonian University, Queen University Belfast, and University of Leeds. He has previously he's received his bachelor Engineering, honors in degree in Electronic and Telecommunication Engineering from Waseda University, Japan, master degree in Digital Communication from Monash University, Australia, and PhD in Electronic and Electrical Engineering from the University of Leeds, UK. He has held industrial position at Oracle, PricewaterhouseCoopers, Accenture, and Telstra. Dr. Prangono has co-authored over 2,000 papers in leading international conferences and journals, and contributed to 3 book chapters. He has served as vice chair and technical program committee member in numerous international conferences, such as IEEE SPCC and GlobeCom. He also served as a referee of some renowned journals and conferences, such as IEEE Transaction on Industrial Informatics, IEEE Transaction on Power Delivery, IEEE Communication Magazine, IEEE Computer, IEEE GlobeCom, IEEE ICC, Elsevier Optical Switching, and Networking, and etc. Now he is a member of Geometric Modeling and Pattern Recognition Research Group. Okay. The title that will be presented by our keynote speaker today is Internet of Things and Smart Grid Cybersecurity. The time for the presentation is 20 minutes and 30 minutes for discussion. Dr. Bernardi Prangono, now the session is used for 20-minute presentation. Please. Hello, Dr. Bernardi.
Right. I need to unmute it. Thank you for the nice introduction, Dr. Alia, and thank you for inviting me for the conference. I'm very happy to be part of the conference today. Yes, so let me share my screen. Okay, so can you see my share screen clearly? Yeah.
Yes.
Okay.
Yeah, clearly.
All right.
Very clear. All
Okay,
right.
thank you. Yes. Thank you again. So my topic today is about Internet of Things and smart grid cybersecurity. So the outline of my topic, I will talk a bit about the introduction of the topic, and then a bit introduction on IoT, Internet of Things, and also to industrial IoT. And we'll talk about IoT-based smart grid and discuss more recent or renowned attacks, cyber attacks on the IIoT and also in smart grid, and some of the challenges and mitigation techniques that to prevent or reduce cyber attacks. So if we look at today's news or in the headlines, so we will see that cyber attack is becoming very more frequent, more complex, and it's harder to defend because they are implementing more advanced and complex techniques. So some of the type of the cyber attacks, for example, like denial of service, like DOS, social engineering or phishing, malware, ransomware, advanced persistence and that cyber attacks have become like daily news. So especially when we look at this current pandemic. So a lot of, for example, like social engineering and phishing attacks has been happening, and trying to lure people to click on COVID-19 related URL, the website, etc. Trying to attract people to give more information about COVID-19, etc. So in fact, actually, a lot of successful cyber attacks has been due to this phishing attack. And a lot of data has been generated on like in the last decades. So to 5 billion gigabytes of data has been generated on a daily basis in 2012, but in 2020, we expected to have 1.7 billion new information. So cyber security that we will discuss today is about the set of technologies and process designed to protect networks, computers, program from attack, damage, and unauthorized access. So when we discuss about the IoT, so Internet of Things is all around us actually. So in basically any devices or object equipped with sensors which can exchange information through the network without human intervention, they can categorize or group as classified as IoT, even though since the term coined in 1999. So there's a lot of definition about IoT, but this is probably the kind of like general definition of the IoT. So IoT communicate device to another device or connect machine to machine directly without human intervention. They can exchange information between devices, etc. So today IoT is basically moving into all and every sector, so opening new opportunities and new challenges. IoT application has been used in like smart meters and smart thermostat, smart home, to smart grid and smart cities. With IoT, basically enable physical objects to make from better objects to make better response to environmental changes and also make informed decision. So the growth of the machine-to-machine communication over the last decade has provided communication paradigm that has enabled ubiquitous connectivity between devices with the ability to communicate autonomously without human intervention. So IoT has the potential to become one of the most disruptive technologies in decades. IoT enables digital connectivity to devices and sensors to reach almost any places that previously unthinkable. So by 2025, so there's one prediction actually. So there will be 100 billion IoT devices in the world. Well, this is probably more kind of optimistic prediction. There are more less optimistic prediction somewhere else as well. So and various IoT implementation is in place for smart home to smart grid, from e-health to industry 4.0. So IoT is considered as the next step evolution of our current grid networks for the smart grid, especially. So if we look at the industrial control system around us, or the SCADA, supervisory control and data acquisition. So IoT has been implemented in different ICS and SCADA system that been heavily used in national critical infrastructure. For example, from kind of water treatment, in financial institution, in smart grid, also in manufacturing. So this type of IoT is what we call it like industrial IoT, which is a subset of the IoT technologies that implemented to enhance manufacturing and industrial process. The key enabler technology to deliver a comprehensive product structure as demanded by Industry 4.0. Numerous technologies such as AI, big data analytics, cloud computing, blockchain, M2M, robotics, and cybersecurity are embedded into industrial processes in industrial IoT. So IoT also been implemented in smart grid. So smart grid, also known as the next generation of the power grid, is considered as a power grid infrastructure with advanced information and communication technologies, or ICT, that will enhance the efficiency, availability, and reliability of power systems. So various devices are required in smart grid for monitoring, analyzing, and controlling the power grid. The ICT innovations such as IoT play major roles in smart grid to be enabled to enhance the efficiency, availability, and reliability of power systems by supporting various network functions throughout the generation, transmission, distribution, and consumption of the electric power. IoT devices such as sensors, actuators, smart meters have been implemented to monitor various areas in smart grid ecosystem. So as the smart grid is one of the largest and the most complex IoT implementation in the world. So because basically smart grid can potentially connect 100,000 or even millions of IoT devices distributed in very large areas, running in different communication protocols, which is give us more challenges that we will discuss later. So the adoption of the IIoT in smart grid can offer benefits, including better capacity for planning, faster service, improved decision making, and enhanced safety and reliability. So when we look at the smart grid architecture, so different with the current power grids. So in smart grid, normally we have like two flows or two lines. We call it like power, like power flow and information flow. So the power flow is like when the power from the generated generator transmission go to distribution. But then for the consumption, because in smart grid we have like a dual, like consumer can also be a producer. And then in information flow, you have this wide area networks and also network neighborhood area network and the home area networks. So while like will we see in this smart grids basically, so they perform the two-way communication flow between distributor and consumer, like what we see in the figure. While in traditional power grid only has one-way communication flow from distributor to consumer. So unlike traditional power grid, so smart grid also provide on-demand service that able fit to consumer requirements, and then this will kind of bring another challenges in cybersecurity perspective. So in IoT-based smart grids, so IoT is implemented in different areas from monitoring to operation. IoT have been deployed to monitor to the substation, RTU, in smart home, etc. The IoT facilitates a smarter and more connected grid by enabling bidirectional information flow and connectivity throughout the grid infrastructure. Since IoT-based market will consist potentially millions of nodes, it has the largest attack surface for an IoT-focused cyber attack. So will as smart grid or power grids consider critical infrastructure, so any attack on the critical infrastructure will have very big consequences. So in smart grid, like different can be classified into different like classification in terms of availability, integrity, and confidentiality. And for example, if we look at DDoS attacks, so this is if we have like 100 gigabit per second DDoS attack, which is trying to cripple a specific object like smart grid. In 2003, we have less than 100 gigabit per second. In 2020, it's around like 12 times of the scale. So, and the impact of cyber attack, they can bring the power down and change, for example, normal frequency like from 50 hertz to 60 hertz, etc. So the two main reasons that make security in IIoT more complex is because currently there is no single standard that defines the IIoT, and there are different standards and regulatory groups that provide specific direction in different segments in IIoT. So some of the example of the cyber attacks in industrial IoT, one of the main cyber attacks is the Stuxnet that attacked Iranian's nuclear power, so destroying uranium enrichment in 2009. And 2015, we have the Black Energy malware, the cyber attack on the SCADA system on power grid in Ukraine. Also in 2016, there's attack using DIN is the service provider, but is also provide service for domain name system with cripple disrupt access to popular websites such as Netflix, PayPal, etc. So they use basically using DDoS attack with using the IoT devices with the Mirai botnet. So this attack is becoming more kind of easier for both attackers, basically because there are some other free tools like this Showdown. They can basically you can search and disclose another thing about the IoT devices vulnerabilities and also sensitive information such as IP address, the open ports, etc. So for example, like that one has been used for both white hacker and also the black hacker. So in there is many ways the attacks can reach the ICS on SCADA, for example, using the removal media, which is used in the Stuxnet, or phishings, and also software vulnerabilities. So ICS has been has been the main target of the malware attacks. So energy, as seen in this graph here. So energy and critical manufacturing, water and wastewater system has been part of the main target. So how we mitigate the cyber attacks? So there are some aspects how to mitigate it. So because new threats are emerging every day, some of which have previously been unknown, making it very hard to eliminate cybersecurity attacks. So there are some mitigation plans, so for example, using access control, encryption, and also authentication, regular security patches and updates, physical security, and also using intrusion detection system like IDS, because if the all above mentioned access control, encryption, etc., are applicable when defending the IoT smart grid against attack initiated by attacker outside the grid. However, if the attacker is already inside the system, so IDS is very useful.
Yeah.
And yeah, okay. So, and also kind of like a blockchain, which is kind of electronic distributed ledger, which is popular emerging technology to maintain privacy. So it's been also implemented in smart grids to maintain privacy. So this is like a sample of using the IDS implemented in SCADA. So using the multi-layer, so the compared to traditional SCADA structure, this structure here is divide the normal corporate network into new corporate network, including enterprise server, and then also corporate and DMZ or demilitarized zones. And cyber, and because there's many things that been used as well. So the use of AI or machine learning and cybersecurity also been widely implemented. For example, in they use the support vector machine, for example, to classify different attacks, or built using different machine learning techniques. For example, for SCM and KNN to build IDS, intrusion detection system, or use different things, because basically this one of the current trend to mitigate the cyber attacks. So there are challenges ahead, and we see in this diagram here. So it's projected rise in number of cyber attacks from 2015 and 2020. So it's about like 2.5 times or almost 3 times cyber attacks has been happening since 2015 to 2020. So in summary, so we see that IT is moving into virtually every sector, opening new opportunities and new challenges. So we see the IoT application from smart meters to smart grid, then to smart cities. Smart grid is essential part of the sustainable smart city to ensuring reliability and availability and efficiency of the power grids. Since the IoT-based market will consist potentially millions of nodes, it has the largest attack surface, largest opportunities for the hackers to trying to attack the target one as a one of critical infrastructure, because it's one as a one of the critical infrastructure. The consequences will be devastated. And despite of the challenges, the use of IoT is shown to improve the existing grid networks to facilitate better monitoring and control of the power grids. It is therefore it's necessary to focus on the security issues during the different phases of designing of the smart grid, the IoT based smart grids, implementing and integrating the IoT devices in the smart grid. Okay, thank you very much for the attention.
Okay, thank you very much, Dr. Bernardi Pranggono. How do I call you? Ben or
Yeah, Bernardi should be fine.
Bernardi? Okay. You know, there's this issue is very interesting right now, because in any aspect, IoT is developed very fast. I believe that's including the in the smart grid. By exposing the grid, smart grid, to the IoT, any threats is open wide. I believe something like that. So in the future, of course, the security need to be improved. Now we go to the chat room. We have a question from Dr. Zaini. Today, PV price is getting cheaper and cheaper. What is the role of IoT to manage such distribution generation effectively without causing instability problem in the power grid? Distributed generation, I mean. Okay, please.
Okay, let's see the question. Okay. All right. Okay, so because basically, yes, so the PV price is getting cheaper and cheaper, and there's the role of IoT to manage such distribution generation effectively without causing stability problem in the power grid. Well, the IoT is supposed to be make it smart grid more efficient and reliable, but because because there is like a kind of the IoT is not from you know, is from the, it's basically is from computer engineering perspective or the electronics side. It is the embedded system. So even though from the as a security researcher, so IoT has been kind of notorious because a lot of issue with IoT. So, and with the smart grid actually, because they want to implement the ICT to make it, well, better power grid compared to the traditional power grid. So we kind of need to be aware, and when we designing the or adopting the IoT into a smart grid in every aspect, like the smart grid has been used in, for example, in the smart home using the smart meter, etc. Which, and then if we look at okay, this diagram here. So basically in this the home area network where there's a lot of IoT devices has been implemented first. So, and then there's also other IoT devices that's been implemented in like a substation, for example, in the remote area. That's also vulnerable to cyber attacks. So when we basically the kind of like a general answer is basically would like to, when we need to well, as a smart grid engineer, etc., need to adopt the IoT, need to be careful because a lot of IoT doesn't have appropriate or suitable security in place. For example, the main issue with IoT is because when we design IoT, like computer engineering or engineer, etc., so as we want to design IoT because as small as possible and as cheap as possible, and because of the limitation of the hardware, so it is difficult to implement kind of advanced, for example, encryption techniques that normally we can do it in, for example, our mobile phone or laptop. But with IoT devices, some IoT devices less than say $5 or etc. It is difficult. And many IoT devices have been used in cyber attack, for example, in Mirai DDoS attack, distributed DOS attack. So they're coming from a lot of cheap IoT devices that doesn't have suitable encryption, for example. So people doesn't change their default username and password, etc. So they can be hijacked by the hackers to be part of the botnet system. I hope that kind of answer your question.
Dr. Zaini, any comment from the explanation of Dr. Bernard? Hello? Okay, we can go through the next question, Dr. Bernardi.
Okay.
About the cyber attacks and DOS attacks that carried out all the times, including the smart grid system. How do we know the attack? You may give the explanation about this.
Yes, so how do we detect and overcome DOS attacks that carried out on smart grid system that have been connected in the IoT system? Do you have to do a system scan, or is another better way? So there is different methods to can be used for detecting DDoS attacks. So because well, DDoS attack is kind of very very hard to defend for the cybersecurity perspective, and this is very hard to defend, and that we see in the in one of the slides. So and we can see is because DDoS basically is very hard to defend, but this is also very easy to generate. So a lot of hackers actually in the black market, they can actually buy to attack specific target, buy from like kind of internet service provider, but it's illegal internet service provider basically. In the UK, there's been one of the like a kind of teenager hacker has been arrested because of providing this DDoS or this botnet attack to attack specific target. So some of the methods they use to defend DDoS attack is implementing kind of well, if your for example, if your website is connected to the cloud, so they use the service provided by the cloud, and they can detect basically, so using kind of AI or machine learning technology to detect anomaly packets. So if, for example, if they have normal, so they have kind of a baseline traffic. So if there are the normal traffic is say like have like a 10 gigabit per second or something, and then suddenly you have this more than 10 gigabit per second. So it's basically the system will raise an alarms, and they can do it automatically, or they alert the system administrator to alert about the issues, and they will check if the traffic coming in is genuine, or is benign, or is malicious kind of attack. So this is basically can be done as in many service provider. They kind of provide this kind of services, but like big companies like Amazon or Google, they have their own system. So yes, DDoS is very hard to defend, and security researchers is looking to use AI to trying to better defend against the DDoS attack. I hope that answer your question.
The question from Mr. Ridwan, yeah, Ahmad Ridwan. Is there any comment or additional question from Ahmad Ridwan regarding with this question?
I think he already answers. So thank you for answering my question. So I should move to next question.
Okay, all right. Any
So
research or investigation that implementation of IoT successfully increase reliability of smart grid, may in UK areas especially? If any, how is about its implementation in UK? So, Mr. Hasbi Fali wondering about this IoT.
yes, interesting question, and honestly, actually, I don't have any data actually. So IoT is usually increase the reliability of smart grid in the especially in the UK, but in general actually. So because IoT has been used for to increase the efficiency of the smart grid, that's been used not just in the UK, but mainly also in the US. It's been you can read academic papers about it, and then because normally the convenience and security is not go hand in hand, isn't it? So many people, they trying to use like a simple password, for example, instead of a very complex password. And this complex password, the simple password is basically, it's very easy to crack, etc. So smart grid in general has been implemented in the UK. So some of the power companies, they implemented smart grid. So in the plan by the government is actually they basically had planned to implement or install the smart meter, which is also part of the smart grid in 50 million household in the UK by 2020. And this was a plan, but actually because of different problems, issues, so the plan has been kind of rescheduled actually, because they admit they cannot install these 50 million smart meters by 2020, which is months. Now it's already in November, so like and only like 2 months time. And yes, so in the UK, it's been slowly implemented in as far as in the UK. Is that, hope that answer the question?
Okay, from your explanation, that's in UK, smart grid seem that's all of them connected to IoT. In terms of the player, what is a player in smart grid in the UK? Is any household also have a game in smart grid?
Yes, so basically one of the characteristics of smart grid is basically as a consumer, you also can be a producer, like a two-way communication instead of one-way communication. So I don't have like a kind of detailed data actually how many consumer and producer in the UK for this smart grid area. So basically if they have, for example, like a solar panel, etc. So in theory, basically they can also sell their electricity, the power back to the grid if they have like a surplus, etc. And if also if you have like a kind of private wind turbine, etc. So they can basically sell to the power companies. But this is not really kind of common because, well, as you know, in the UK there is not much solar power, not like in the for example in Australia, which is kind of there's more suitable for solar power, and also in the US. So in the UK, renewable energy, they more using kind of the wind energy, using the wind turbine, etc. Yeah, so that's does that answer your question?
Yeah, you answer my question, but interesting. Not easy implemented in Indonesia like that, right?
Well, Indonesia actually has big potential actually with the solar power. But yes, so because the smart grid rely on very good infrastructure, etc., which is yeah, kind of it's even in the UK, it's not easy to implement. Like many people out there, actually, they don't want to, for example, use a smart meter because they think, well, you know, they think smart meter is invasion of the privacy, etc. And there's like a lot of conspiracy theory, like what we heard about conspiracy theory about the 5G implementation regarding with the COVID-19 effects. So this, yeah, even in the UK, actually, many people has this kind of opinions, and they don't want to have smart meters in their home, etc.
Okay, now we go to the next question from Mr. Rohais. He's wondering about the use of cloud services for the small companies. What is your opinion about this?
So most small companies are scared to use cloud services and more comfortable to use local server for their data storage. So this method will expose themselves to the cyber threat, especially when they migrate to smart process. What do you think? Okay, if I clearly understand the question. So cloud computing has many benefits. One of the benefits is actually because they only charge what you're going to use, like pay as you use or pay as you go. So many small and medium companies, they cannot afford to have, for example, abundant resources in computing resources, or they cannot employ, for example, dedicated database administrator, etc., which is very normally it's very expensive, or employ their security engineer. So they turn to use these cloud services, which is, for example, using this AWS in Amazon, etc., which is you can use their services, the cloud, the computing resources, and also the database administrator, the DPA, the network engineer, security engineer, etc. So in when you need it, and this normally been adopted by many small and medium companies, like in the UK, also in the US, because they can have the same infrastructure that what Amazon has, using when they need it. So they can, for example, if they have like more, if they're selling something in the internet and they have more customers, so they can just increase their what you call it, their usage and increase their capacity. So, but if they have less customer, so less demands or less transaction, so they will decrease the capacity. So they don't need to hire dedicated DPA or security engineer or the expensive hardware by themselves. So they can basically share it with other. They can share it with other small and other medium companies to use the specific, the expensive hardware and software. But yes, your concern is also you mentioned is also true, because basically when you use cloud, so it means your data is not local, but actually your data is stored in the cloud. So this well, the company need to, when they decided to use the cloud computing services, so they need to think about what data need to store in the cloud, on what data need to store in the local storage. And for small and medium companies, probably it's not that big issues, but for say big companies, and especially for government. So like in the UK, so this government is basically they can't use, for example, use the cloud storage, the cloud services, because of the security issues. If they have like confidential data, etc., so they need to have store it in the local storage. So they, instead of using the public clouds, so they need to use what they call it private cloud. So that's basically kind of the securities security as perspective that you asked in your question. So I hope that
we still have one
question.
Maybe the last question, Dr. Bernard.
Okay.
From Mr. Sarkawi Samsudin. The question is, what we have to do for protection our smart grid system?
Uh, well, the general rule of thumbs is basically when the smart grid engineer need to design the smart grid, so they need to think about the security aspect in every layer, in every department. So because security has been kind of not been as a priority area for especially in the industrial control system, etc. So because they think, because they are not connected to outside world, so they do not think about the security aspect. So for example, like when they transmit from sensor to actuators, or from the substation to the SMI and SCADA system, they transfer the data in clear text, for example, because this is the because they want to basically transfer data as fast as possible, and they don't worry about the security. But now with this market, basically, because if you connect it to the network, it means your data is has a potential security risk. So want to basically need to think about security aspect when you design the your smart grid system. So in from when you deploy your substation, or from the generation, or from the smart meter, how they transfer data smart meter to the to the gateway, etc. We're using IoT because normally IoT have this perception layer, the gateway layer, and the the network layer. So how they transfer the data from its layer? Is it transfer securely, or if not, what need to do? Because IoT has limitation in terms of kind of encryption and computing resources, etc. I hope. And yeah, so one other thing actually, so one of the issue in the cybersecurity security issue is actually the user awareness and user education is very important. Like a lot of attacks, a lot of cyber attacks can be prevented with the proper or suitable training for the users. So one of the, I don't know if I had it in my slide actually. So one of the research says, so about around 60, 50, I think it's 50, 60% cyber attacks for the normal companies, they can be prevented by user training or the suitable user training. Because like what we said, many that I mentioned before, like many successful cyber attacks has been part of using the social engineering, like phishing attacks, like people clicking on the email, the link on the email that looks like, okay, this link from your bank, etc. And they click it because it's the URL. It looks like from the legitimate bank, the website, but actually it's not. So and then they install behind the scene the malware that can give the attacker access not to your computer. Yes, access to your computer, but the main problem, the main issue, the main target is if you are working in critical infrastructure company, for example. So the main target is the companies. So if they can access your computer, so hopefully they can have access to your company's network, and hopefully then they can have access to other more confidential data.
Okay, thank you very much, Dr. Bernardi.
Okay,
now we
thank
come
you.
up to the end of the session. But before that, I want to say Assalamualaikum from Dr. Yosef Rizal, maybe your friend, yeah?
Yeah, Waalaikumsalam warahmatullah. Yes.
Before we close this session, I like to thanks to Dr. Bernardi for very interactive presentation and discussion, hot discussion.
Thank
Maybe
you.
if we continue, still have another discussion, but the time is limited for us. And then also for the audience, I like to thank, still have 157 audience right now. Even it's not the favorable time for discussion and presentation right now, but I respect what we have done today. So now thank you for your attention, and thank you, Dr. Bernardi. Maybe
Thank
you
you.
have contact with my friend that's interested in with the grid, yeah, maybe through Dr. Nasir Soni or Bu Adrianti. Yeah, very nice, very hot. Then now I return to the host right now. Thank you very much.
Thank you.
As the last session and the amazing knowledge we got by Dr. Bernard from United Kingdom, we are almost at the end of conference, but still not finished yet. We will present you the announcement, but before that we have to break. And while waiting, we present to you a traditional dance video. Enjoy the video. Ladies and gentlemen, you must be waiting for this. The announcement of online presentation will be conducted by the organizing committee. Please welcome Dr. Adrianti. The time is yours.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. We will to this announce the best paper that has been assessed by our team. Let me show the PowerPoint presentation. Is it can be seen?
Yes, now, yeah.
Okay, we will announce the best paper. Actually, we also want to announce best video, but unfortunately, our team is still need more time to assessing the video that we received recently. Therefore, the best video will be posted on CITES website soon. Okay, let's start. From mechanical engineering, the best paper is with title Effect of Particle Size on Addition Strength of Bovine Hydroxyapatite Layer on Ti12CR coated by using electrophoretic deposition EPD method. The author is Gunawarman, Zaimul Arif, Nuzul Fiki Nuswantoro, John Afi, and Mitsuo Nomi. It's from Universitas Andalas. And the next, from industrial engineering, the winner is with title Two-Dimensional Warranties Cost Analysis for a multi-component product protected by Lemon's Laws. The author is Heni Husniah and Bermawi P. Iskandar from Universitas Langlang Buana and Institut Teknologi Bandung. Next, from electrical engineering, the title is Optimization Signal Quality on Cellular Network Based on Tilting Antenna. The author is Hanaude Andre, Muhammad Gozal, Fitrilina, Baharudin, Rudy Fernandez, and Asrial. They're from Universitas Andalas. Next, from civil engineering, the winner with title The Dynamic Load Test of Two Seismic Resistance of Steel Structure EBF and RBS. The author is R. G.I. Rastandi, M. Orientilize, Cindika Asilah, Dwinita Apritasari. They are from Universitas Indonesia. And the last one from environmental engineering, the winner with title Application of Life Cycle Assessment LCA on Green Tea Product, case study in the X company. The author is Gusti Mila from Universitas Andalas. Congratulations for all the winner. The committee will send you certificate for the winner. And thank you for listening, and I give it back to the host. Thank you.
Applause and big reward for all the winner, and hopefully all of the knowledge from research will be useful. So, the last segment is closing speech from Vice Dean Faculty of Engineering. Let's invite Professor Vera Sartia Bakhtihar, PhD. The floor is yours.
Okay, thank you very much for MC. Assalamualaikum warahmatullahi wabarakatuh. First of all, let us say thanks to Allah Subhanahu wa Ta'ala, which have given guidance and blessing to us. Therefore, we can gather here in this international seminar without hindrance of any. Our salawat and greeting are always delivered on our great Prophet Muhammad Sallallahu Alaihi Wasallam, which has brought us from darkness to bright. Good afternoon, ladies and gentlemen. Alhamdulillah, we have reached the end of the second conference on innovation in engineering and business for better future, and it is my task to provide some closing remarks. Alhamdulillah, the seminar going well and smoothly, although only the keynote speaker could be held in person, while the participant only sent video presentation. However, from the video presentation sent by all participants, we can still share knowledge from all participants and can still determine the best presenter from this seminar. We know that this second seminar is very different from the first seminar. The first seminar in 2018 was held in Padang City. However, due to the COVID-19, the second seminar had to be held online. We are concerned about the COVID-19, so participants who have a big desire to come to West Sumatra cannot come here, but the committee can present video of tourist area in West Seminar. From the video, we hope that for the next third seminar, participants will be able to see firsthand the West Sumatra. Ladies and gentlemen, on behalf of the board of this seminar, I thank you very much for your good attention during the program taking place. And my special thanks to those who have done their duty delivering item of our program today. First of all, I would like to thank all of keynote speakers today, namely Professor Muhammad Nasir Tamim from University Technology Malaysia, Professor Minoru Sasaki from Gifu University, Japan, Professor Masami Furuchi from Kanazawa University, Japan, Dr. Bernardi Prangono from Sheffield Hallam University, United Kingdom, and the last one, Professor Gunawarman from Andalas University. Thank you for sharing your knowledge, which are very useful for all participants. Secondly, I want to thank all the other speakers and panel members. You present have been invaluable, and without any doubt has helped make the event a great success. We hope that all of you can participate again in future seminars. A further thank to the Rector of Andalas University, Professor Yuliandri, whose contribution we highly value for this event. Then thanks to the Dean of the Faculty of Engineering, Andalas University, Professor Ikhwana Alfitri, for all the support so that this event running well. We greatly appreciate to the chairman of the committee, Dr. Agnovia Susanti, and all committee members consisting of lecturers and students who have fully participated so that this event was very successful. Thank you very much. Finally, I also say many thanks to all of our students who prepare everything we need to carry out our seminar from the morning to the afternoon. Finally, please forgive us for the mistakes you might have during the seminar going on. We hope to see you all again in the next seminar in 2022 in Padang City. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Please, MC.
As the last speech from Mrs. Farah, we, as your master of ceremony, have to sign out. Forgive us for all the mistakes we made. In the name of all the committee, thank you for your attention and contribution. I am Ananda Lelatul Rahmi, and here my partner.
I am Sultan Arif.
And see you on the next 2 years for the third CITES on 2022. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thanks.
di mana tradisi keilmuan mengakar kuat. Kreativitas dan produktivitas diciptakan tiada henti. Kami adalah institusi pendidikan keteknikan yang terdepan di Indonesia dengan reputasi internasional. Fakultas Teknik sudah berdiri selama lebih dari 30 tahun dan telah menjadi bagian penting dalam sejarah pembangunan bangsa. Saat ini, Fakultas Teknik Universitas Andalas terus berkembang, utamanya dalam upaya menghadapi transformasi digital 4.0 dalam bidang pendidikan, riset, dan teknologi. Fakultas Teknik Universitas Andalas adalah kawah Chandra di muka bagi putra-putri terbaik dari seluruh penjuru tanah air untuk berkreativitas dan berkarya berbasis ilmu pengetahuan dan teknologi demi kejayaan bangsa dengan spirit menuju transformasi digital 4.0. Proses pendidikan dan pengajaran dalam bidang akademik yang dilakukan oleh Fakultas Teknik Universitas Andalas ke depan adalah meredefinisi kurikulum. Kurikulum yang akan dipergunakan mengarah pada respon terhadap perubahan yang terjadi hari ini, membangun ekosistem inovasi yang akan memunculkan mahasiswa yang mempunyai daya kreativitas dan produktivitas yang tinggi. Dalam menyongsong transformasi digital 4.0, sarana dan prasarana Fakultas Teknik Universitas Andalas mengacu pada kebijakan anggaran. Hal ini dimaksudkan untuk membuat sinergisitas antara universitas, fakultas, dan jurusan. Sarana dan prasarana Fakultas Teknik pada bidang kemahasiswaan menitik beratkan pada pengembangan skill dan bakat mahasiswa sesuai dengan bidang yang dipelajarinya.
Ya, di elektro itu kan kita belajar tentang mikrokontroler, mikroprosesor. Itu berkaitan dengan komponen-komponen yang kami gunakan di dalam pembuatan robot. Robot yang sudah dibikin itu robot hexapod. Robot itu digunakan untuk memadamkan api.
Selain memfasilitasi mahasiswa untuk berkreativitas dalam berbagai perlombaan, Fakultas Teknik Universitas Andalas juga menyelenggarakan penyambutan mahasiswa baru setiap tahunnya. Dengan mengoptimalkan kebijakan anggaran, menguatkan pelayanan terbaik, serta merespon perkembangan teknologi, transformasi digital 4.0 adalah semangat dan harapan yang dicita-citakan Fakultas Teknik Universitas Andalas ke depan.
Hai, Assalamualaikum. Nama saya Shania Pritiwi, jurusan Teknik Mesin 2017.
Hai, nama saya Andi Ondia Siraf, saya mahasiswa Teknik Mesin 2017.
Nah, di sini kami akan beritahu apa sih yang kalian kerjakan di jurusan Teknik Mesin Universitas Andalas.
Nah, di teknik mesin itu ada 4 bidang yang bisa kita kuasai. Bidang yang pertama adalah rekayasa manufaktur. Salah satu mata kuliah yang bisa kita ambil adalah menggambar mesin dan CAD. Di mata kuliah ini kita akan mempelajari bagaimana sih cara menggambar mesin dan komponen lainnya menggunakan software seperti AutoCAD, SolidWorks, Fusion, dan yang lainnya.
Selain bidang itu, ada juga mata kuliah mekatronika. Nah, mekatronika ini merupakan salah satu mata kuliah yang saya gemari. Kenapa? Karena kita mempelajari teknologi yang lebih modern, seperti software dan hardware komputer, ilmu komunikasi, ilmu material, dan juga kecerdasan buatan, di mana ilmu tersebut bisa kita buat robot dan mekatronik.
Yang kedua, ada bidang keahlian rekayasa material. Salah satu mata kuliah yang bisa kita ambil adalah material teknik. Jadi di mata kuliah ini kita akan mempelajari hubungan antara struktur mikro dan sifat-sifat bahan teknik, terutama logam. Dari situ kita bisa mengetahui bagaimana sih cara membuat material yang kuat, tahan karat, dan tidak mudah aus.
Nah, selain bidang itu, ada juga bidang rekayasa konstruksi. Di bidang ini kita mempelajari tentang mekanika kekuatan material. Mekanika kekuatan material ini salah satu bidang yang saya sangat sukai. Kenapa? Karena di sini kita bisa mempelajari struktur material akibat suatu pembebanan.
Dan yang terakhir, ada bidang keahlian rekayasa konversi dan energi. Mata kuliah yang sangat saya gemari adalah termodinamika 2. Di termodinamika 2 ini kita akan mempelajari tentang apa itu siklus Otto. Siklus Otto adalah siklus yang ada pada mesin kendaraan. Jadi dari situ kita bisa mengetahui berapa sih bahan bakar yang terpakai pada saat kita berkendara. Dan untuk menghitung itu kita bisa menggunakan alat yang namanya adalah dyno test.
Nah, selain itu, jurusan Teknik Mesin Universitas Andalas juga memiliki kelas berbahasa Inggris, yaitu kelas internasional. Di sana, kalian dapat mempelajari tentang bahasa-bahasa. Nah, kalau tidak ada kelas, seru banget di lab. Di sana, kita bisa berinteraksi dengan mahasiswa-mahasiswa lain, berbicara tentang riset-riset, bicara tentang akademis dan non-akademis.
Tapi kita biasanya nggak melakukannya di lab aja sih. Di sini juga ada kantin, gazebo, di mana kita biasanya duduk bareng-bareng sama teman-teman sambil buka laptop, sambil ngerjain tugas. Dan juga ada taman, di mana kita biasanya berinteraksi dengan mahasiswa-mahasiswa lain sambil sharing-sharing pengalaman tentang mata-mata kuliah yang sudah diambil oleh mereka.
Nah, jurusan Teknik Mesin juga mempunyai perpustakaan yang lengkap. Di sana kita bisa belajar dengan nyaman.
Jadi di kampus kita nggak harus belajar aja sih. Di sini kita juga bisa memanfaatkan fasilitas-fasilitas yang ada untuk melakukan kegiatan lain seperti olahraga. Dengan area unan yang sangat luas dan udara yang segar, kita bisa memanfaatkannya untuk melakukan olahraga.
Nah, bener juga. Biasanya aku dan teman-teman suka jogging. Kalau kamu?
Nah, kalau aku biasanya tanding basket, tanding tenis meja, dan volley bareng teman-teman.
Nah, selain olahraga tersebut, ilmu yang kita dapat dari jurusan Teknik Mesin Universitas Andalas juga bisa kita aplikasikan di luar area kampus.
Betul tuh. Di sini, kita juga dididik agar menjadi lulusan yang terbaik yang mampu bersaing di pasar global, melaksanakan penelitian dasar dan terapan yang inovatif untuk menunjang pembangunan nasional dan pengembangan ilmu pengetahuan dan teknologi di Indonesia. Selain itu, jurusan Teknik Mesin juga berperan aktif dalam pemecahan berbagai masalah di masyarakat dalam bidang teknologi.
Jurusan Teknik Mesin adalah salah satu cabang ilmu keteknikan yang paling tua dan memiliki cakupan ilmu yang sangat luas. Sarjana jurusan Teknik Mesin Universitas Andalas dibekali dengan berbagai kompetensi utama dalam bidang teknik mesin seperti kemampuan analisis, rancangan, pengujian, manufaktur, kontrol, pemecahan masalah, dan perawatan sistem-sistem mekanik serta berbagai kompetensi pendukung lainnya yang dibutuhkan di dunia kerja.